Well, hello everybody. I hope you are all doing well. It is good to see you today. Can you see and hear me? Let's see, I gotta wait for the chat thing to load. Beautiful, thank you, Lenina. Hello everybody. Welcome back to Paleontologizing. Welcome back to Eastern Utah. Welcome back to the earliest Cretaceous Cedar Mountain Formation, where we're digging up dinosaurs. At least one, maybe two, possibly more new species of dinosaur here in the earliest Cretaceous Cedar Mountain Formation. Rock's about 142 million years old. It's good to be here, and I'm glad you could make it too. If it's your very first time, allow me to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. Paleontologist, as you hopefully know already, is a scientist who studies fossils. I work on dinosaur fossils in particular, and we're going to be showing you some of those today. Given that this is, you know, not just how I make my living, but a means of science outreach, I want you to ask questions today. Whatever you might be wondering about, whether it's in, particular to what we're working on here, whether you've got broader questions about natural history, about extinction or evolution or the fossil record, maybe about the very philosophy of science itself, don't hesitate to ask those questions. It's what this is all about. Thanks to the magic of Twitch and satellite internet, I can broadcast to you from the middle of nowhere out in the Utah desert, kind of near the town of Moab, but not close to it. And yeah, I don't know. It's great to be here. And again, I know I keep saying this, but I'm glad you're here too. Let's see who's here in the chat. Looneysaurus and Otto the Potato, thank you both for your resubs. I appreciate that. Hello, Paleo Ken. We miss you, man. Hope you're doing well, Ken. It's good to see you. And Dr. Tara, I did just see that a few minutes ago. Yeah, as I was eating lunch, prehistoric planet Ice Age, I think they're calling it. It's set in the Pleistocene. That's going to be cool. Comes out November 26th. Be neat stuff. I'm sure Fisher's excited about that. Hello, everybody. It is good to see Tara. Hello. Seymour says, why is there a Utah raptor but no Massachusetts raptor? Because there's been no found in Massachusetts. The type locality for being in the same formation that Utah raptor is from, the Cedar Mountain Formation, but these rocks are older than Utah raptor. So we don't expect to find any Utah raptor here, but there's always a possibility we'll find its ancestor, which would be pretty cool. And hello to you too, nice shirt. Yeah. But they show Rancho La Brea. They better, Dr. Hubbs, yeah. Kenny says, is there a Georgia raptor? No. The only dromaeosaurs that are named after states are Utah raptor and Dakota raptor, which is, in my opinion, not valid. I think it's a chimera. I think that's pretty well established at this point. And Wyoming, not a dromaeosaur. That's from Wyoming. I can't think of any other. Colorado. Anywho, Murph, good to see you too. Hello. Welcome. And yeah, there you go, Otto. Yeah. Dakota raptor, probably not legit in my opinion. But that's a story for another time. And Jurassic World take note. There you go, Dr. Tara. Yeah. Yeah. And yeah, Kenny HY. Yeah, no Georgia raptor. I don't think Georgia actually has any Mesozoic dinosaur fossils that have been described from there. The east of the United States is not well known for its dinosaur fossils. You've got some dinosaurs in Arkansas, like Arkansaurus. I have Arkansas in the brain because Selena Suarez is here, and she teaches in Arkansas at the University of Arkansas. So we'll meet her in a bit. But yeah, Arkansas has got some dinosaur remains. Missouri has some. Maryland might have the most from the East Coast. New Jersey is where Hadrosaurus and Dryptosaurus are from. extra marine strata there. Yeah. But not a whole lot else out on the East Coast. Lots of trackways, lots of footprints in places like the Connecticut River Valley, the U.S. states of Connecticut and New York. But apart from that, yeah, the eastern U.S., not well known for its dinosaurs. I'm gonna sneeze. Excuse me. And it was nice and bright and clear earlier. Last night, could actually see like a ton of stars. You could see the Milky Way, and now it's gotten hazy again from wildfire smoke. And yeah, that's not ideal. But it is hopefully keeping things a little bit cooler. It's been, again, surprisingly cool. Current temperature is somewhere around 90 degrees Fahrenheit. So yeah, unseasonably cool for this part of the world. We've been very, very lucky. It's also been extraordinarily dry. We've had, I think, one minor rainstorm. It lasted for about 10 minutes or something like that, about a week and a half ago, and that's really it so far. Normally this is like the sort of monsoon season here where you get a bunch of rainfall, just practically nothing. It's been kind of wild. Yeah, and thank you for the blessings, everyone. Yeah, and yeah, there you go, Murph. Yeah, Karen, also from Arkansas. Yes, indeed. She teaches in Arkansas. She's originally from Arizona. But yeah, and Worcestershire-saurus, Stu Moore. Yeah, that'd be a difficult one to pronounce for a lot of folks. And Durus Magnus says, thought upstate New York had some dinosaurs besides footprints. They might have a few. I know Massachusetts has a couple of dinosaurs. That's where Ankylosaurus and Podokesaurus are from. But I'm not sure about upstate New York. I know we've got footprints from there. I don't know if we have body fossils from dinosaurs. Not totally sure. Yeah. There you go, Dr. Terry. Yeah, it wasn't even torrential rain or anything. Yeah. Maybe sneeze again. And then we'll check out the quarry. Maybe I don't have to sneeze. But yeah, anyway, the reason we're in Utah right now is Utah has an absolute wealth of Mesozoic rocks, which contain a tremendous number of important dinosaur fossils. We're excavating here today, so especially if you're new, I want you. That bone that Nick was working on is he found the end of it, and we're still trying to figure out what it is, but it's big. And so let me get some water. I need to move my bag out of the sun. There we go. Let's go take a look around. So, Jim Kirkland and Fisher McDermott left this morning. So, Fisher, hopefully, is on his plane heading back home to Ohio right now. Hopefully they got there in time for him to catch his flight. I know he was nervous about that. And Jim should be back home at this point, too. And Don DeBlue should be coming out to meet us in just a little bit. He might show up during stream today, but he's on his way up from Salt Lake. Excuse me. Goodness. Thank you. But yeah, so Jim's chair is empty today. It's kind of sad, honestly. Well, not totally empty. Nick left his meat circles there. But yeah. Anywho, but we are joined by Dr. Selena Suarez from Arkansas. So, yeah, before you showed up yesterday, we were actually looking at your that little segment in the Dinosaur Frontier book. Have you seen that?
Oh yeah, I haven't finished reading it. Yeah.
I haven't either.
Krista did a really good job.
But yeah. So it's good to have you here.
Yeah, thanks.
Yeah.
It's good to be out.
So
It's
Selena.
been a while since I've been here.
Right. Yeah. When's the last time you?
Man, maybe like. When did they open it up?
Would have been like
07?
Yeah. So I was here for 2 years, maybe. So
Nice. That would have
more
been
than 10 years ago.
before Crystal Geyser or after?
No, it would have been after
yeah.
Crystal Geyser. Like I did Crystal Geyser in 2002. I think.
Gotcha.
So I first came out in 2001.
Okay. When did they film Utah's dinosaur graveyard? That'd have been 05?
Oh gosh, yeah, that would have been.
That's how
2003 or something like that.
that early. Because it came out in
2005.
I think it came out in 06 or 07.
Oh, did it? Okay,
Yeah.
then maybe 2000. Well, yeah, maybe 2005 because
Okay.
they came out to Temple for that too, and I was doing my master's at Temple.
Oh, right,
that
yeah.
was 2003 to 2005. So it
Uh-huh.
must have been something like that.
Nice.
2004, 2005.
Yeah.
Yeah.
So some of my viewers are actually going to recognize you from that because we've watched that a number of times on stream before. And
Nice.
yeah. But yeah. So Selena was with her sister Marina, on that. So yeah, they're twins. You know the whole spiel. They really kind of played that up in the.
Yeah, they did. They're like,
it's pretty
you know,
funny.
you guys need to like talk at the same time, finish each other's sentences. And I was like, I really hate doing that because it drives people nuts. And they're like, no, it's great. You should do it. You should do it. And I'm like, okay,
So
I guess.
I said it seemed like the producers were really pushing for that. Like
Yes,
that doesn't.
they were.
Yeah, and then I mentioned that to somebody, and they're like, "Oh no, they're like that in real life."
Well,
like
I'm like that.
I'm not sure.
We're like that if you get going, but
Yeah.
in general, we try not to do that
Yeah.
because it just confuses people. So
Anyway, it's good to have Selena here.
yeah, got some geology.
Yeah,
Getting my
yeah,
students some experience excavating.
right, yeah. Speaking of students, would you care to introduce yourself to all the good folks watching at home?
Sure.
Yeah.
I'm Clayton. I'm Selena's PhD student at University. And I am digging out some of this yellow cat formation down here.
Yeah, that's where I was yesterday. That's my spot. Hopefully you find some better stuff than I did. Shoot.
Hopefully so.
Yeah.
I did my master's on the chemostratigraphy through the yellow cat.
Oh really? Oh
Yeah.
shoot! So this is like a homecoming for you.
So this is a little bit, yeah.
Nice.
But my are a little bit further west, a little further
Oh,
further
okay,
east.
gotcha. Have you worked in the yellow cat before?
Not digging bones.
Oh, okay,
but
yeah, nice.
sampling a whole lot of rock for
Yeah,
chemostratigraphy.
cool. This is neat. It's like a
Trying to figure out the age of the rocks,
Yeah,
which is always
yeah.
a controversy. The age. But age is key.
exactly, yeah. Well, we'll talk about that in a minute. But I was gonna make a joke about it's like a baby sea turtle returning to its place of birth, where it's like somehow I know this place. But yeah,
Yes.
yeah.
Oh, for sure. This is all the rock looks familiar.
Yeah.
seen this rock before, not for this particular one, but
Uh-huh.
Or from this particular perspective.
or from
Right.
this particular perspective. But
Yeah. Cool. It's good to have you here, Clayton.
thank you.
Yeah. Yeah, because Selena, you were talking about the age of these rocks, and that's been kind of controversial. Like, the folks at BYU seem to think these rocks are a lot younger. For anybody who might be unfamiliar with, oh, and hang on, let me interrupt real quick. We got a raid from Dyson Dinosaur. That's Filippo Bertozza, iguanodont researcher, like I was telling you about. So, Filippo, I hope you're having a good day. Hope you had a good stream. Welcome back. We're talking with Selena Suarez here in the iguanodont quarry, and yeah. But maybe just do like a geochronology 101. How do you figure out how old these rocks are using the methods that you use?
Yeah, so you can't physically date the actual depositional age of a sediment. Right?
Sure,
Because
yeah.
Using tools like detrital-zircon geochronology, so you look at the uranium-lead concentration of detrital zircons, but then to get the age of formation of that rock, that worked for igneous rocks, but not for sedimentary rocks, because those igneous rocks had to exist and gotten weathered before it got deposited in
Right.
a sedimentary rock unit.
So it's like sedimentary rocks are almost recycled in the first place.
Yes.
Yeah, so you can't date them directly. You've got to... Well, how do you do that then?
So we have been using a number of different like cross-disciplinary methods besides just dating. So one method we use is detrital zircon geochronology. So detrital meaning it's been transported, weathered away from a source somewhere and transported along the land surface and redeposited. And that zircon grain gives you a maximum depositional age. So it could be younger.
Right.
A rock that has a youngest grain population that has a max of 120 million years old. It could be 120 million years old, or it could be 1 million years old.
Gotcha.
Right? It could be that age or younger.
So
we do that sequentially in multiple places, like up section. And what you want to see is a younging upward progression of those grains. And that would suggest that they're close to depositional age. Probably not the depositional age, but close to depositional age.
Right.
And then we also add in, that's the tool that my colleague Glenn Sharman at the University of Arkansas uses. And then we use another means of dating, which Clayton did his master's thesis on, which is carbon isotope chemostratigraphy, which tracks major perturbations to the carbon cycle. So if you have a big volcanic eruption and you throw a bunch of CO2 in the atmosphere, it disrupts the carbon cycle. So you have more CO2 in the atmosphere than what you normally do, and usually that results in increased weathering, which draws down CO2, and things get balanced again.
Gotcha. Okay.
So those things usually result in some sort of carbon isotope excursion. Either it gets very negative or very positive, depending on the nature of the eruption.
Right.
Where it was, how ashy it was, and things like that. And so in the Cretaceous, there are a lot of those.
Yeah,
because,
lots of volcanic activity,
starting around the early mid-Cretaceous, seafloor spreading increased, volcanic activity increased, and so you have several major carbon isotope perturbations.
Gotcha.
One of the more famous one is called OAE, which stands for oxygen anoxic event 2, which marks the Cenomanian-Turonian boundary.
And is that around the time that like ichthyosaurs completely die out, and like you have these other groups that just disappear?
I think so.
Yeah, maybe as a direct result of
Don't
that.
quote me on it.
Okay, yeah.
But I think
That's why I'm asking. I don't know for sure.
I don't know for sure, but I'm pretty sure.
Yeah.
So those result in big carbon isotope excursions, and so and those are dated fairly well with biostratigraphy and some geochronology as well. And so we use those as ages as well. So if you see a carbon isotope excursion, you know the date of that isotope excursion.
Yeah.
You can add that into your sequence of your detrital zircon geochronology. Some people add biostratigraphy into that as well. Some people add magnetostratigraphy into it as well. And then more recently, I can't do it personally because I'm not that good with computers, but some of our other students and other colleagues have been bringing in Bayesian age modeling. So we have a probability distribution of each of these ages with stratigraphy. So you plot age on one axis, stratigraphic location on the y-axis, and the probability distribution of the age. So what is the likelihood? Is it a bell-shaped probability for a maximum depositional grain of this? It has to be actually a uniform distribution rather than like a normal distribution.
Sure.
So you add all this stuff in. They do the whole priors thing, and I don't quite understand the priors.
I don't know anything about Bayesian statistics either. So
it's a Bayesian statistics thing that I don't know enough about. But I need to read Bayesian statistics for dummies. But you get this probability curve of the age of your grain. So you have like a median probability with a 95% confidence interval. Yeah. And that's really starting to get much better age constraints with actual error. So like a for real error. So that's what we've been trying to do here and in other places, in other projects that I've been working on, not just the Cedar Mountain Formation, but other Cretaceous age strata north and south of here, and also some Triassic age strata that I've been working on as a separate project. So.
And so the thing that strikes me about this, like geochronology, using all these different methods to determine the ages of these rocks, is just how collaborative it is. Like, there's literally hundreds, if not thousands, of people whose efforts go into determining these things. It's super integrative. You know, no one person does this alone. And
it's not fast, I can tell you that.
Right, yeah.
And a lot of manpower, a lot of man hours, or woman hours, or person hours,
person
whichever,
hours,
person hours.
Working hours.
Working hours. So yeah, but if you want to answer big questions about like the evolution of the biota or the effects of climate change on the evolution of continental species, then you need to compare, distributed across the world, you need to compare the same age rocks to the same age rocks.
Right, yeah.
And the same age fossils to the same age fossils. So you can't say like, well, early Cretaceous-ish. That's
right, you
like
actually need firm
20
dates on
million
these
years.
things. Yeah, you need to make sure that everybody's lined up properly in the rock column, essentially, if you're going to be figuring out patterns of evolution, emergence and disappearance and all kinds of stuff like that, yeah.
That's all the fun and cool, sexy stuff, but...
Uh-huh. Right, yeah.
Less spectacular.
So on that right now, are we talking Valentinian,
I would say they're
Berriasian?
at least Valentinian.
Okay.
Maybe older. I'm not 100% I go back and forth with Jim on this.
Yeah, because Jim is really keen on saying these rocks are about 142 million years old. They're Valentinian.
But we just took a walk out around to look at the stratigraphy here and look at the patterns of stratigraphy, which is a good thing to do sometimes. Just walk around.
For sure, yeah.
Just observe.
Get some perspective.
And certainly we see in the lowest part of the Cedar Mountain Formation wet conditions. They're either waterlogged, kind of like this, or you have silcretes and such.
Yeah.
Or you have redoxomorphic looking paleosols, like paleosols that represent really well drained soils.
Yeah.
Both represent wet, like high precipitation. It's just one's waterlogged, one's wet.
Right.
Jim kind of thinks they're sequential, like he thinks like silcretes and then redoxomorphic paleosols. And before the silcrete, this kaolinite unit that him and Ed Simpson have been talking about.
Yeah.
I'm not sure they necessarily need to be mutually exclusive because the difference is just the drainage.
That would complicate things, yeah.
Yeah, so you could, well, just even over there, I found some silcrete mixed in with redoxomorphic paleosols, and we have that out at Moore Cutoff Road as well. And at Moore Cutoff Road, we have a nice carbon isotope excursion that looks like the positive carbon isotope excursion associated with the Parana Etendeca large igneous province, which is the result of the result of rifting of
in the Atlantic.
It's a result rifting of South Africa.
Oh.
Another large igneous province. Got it. So. Just 30.
You want to get some of those nails? So it's a
135-ish.
Cool.
Middle of the Weiser, it's about 135.
Right here, out on the cliff face over that way, but it just didn't pick up in anything, which can happen. It's not a perfect method.
Would magnetostrat be useful for this kind of thing, or?
No, because we're probably still in the long normal here.
Gotcha.
There's not a lot of,
is there a small nail?
Not a lot of flipping back and forth, yeah. Yeah, so magnetostratigraphy, chat, if you're not familiar with it, Earth's poles will flip, which sounds like something you'd see in a Michael Bay movie or something, like some sort of disaster thing. But it would have been a lot more humdrum than that. Just south is north, north is south. The Earth is not, turning over. It's just like when poles on a magnet flip. And so, yeah, you can look at different particles in rocks and how they're aligned, and you can figure out basically
where the North Pole was.
Where the North Pole was at the time, yeah.
Magnetic North Pole.
Magnetic North, yeah.
Okay, put that nail in.
And so.
Under the nearest.
That's another means of stratigraphy.
Right, yeah.
Chronology, I guess.
Yeah. It's kind of like a barcode, where we usually do it as white and black. White, black, white, black, white, black. And sometimes the flips happen in rapid succession, and sometimes there's a long, normal sequence, like I guess we have for here. So magnetostratigraphy is not particularly useful for this time right now, which is unfortunate.
There's not a lot of reversals.
Right,
yeah. Part of the Cretaceous. So.
But yeah. Anyhow, getting some positive feedbacks later. Wow, she's really cool.
That's 1 meter.
I hope so.
The nail next to the one.
So, anyway, but let me know if you've got any other questions, especially if I happen to miss any while we were talking.
You said that one is off.
That's
right? This is off. So put that nail you're holding where the one is off should be.
Nice Church says it's like being back at KU in Ed's class. That's right, yeah. students, right? That's super cool.
Nice.
Yeah. Small world, right?
Yeah.
Yeah. Those flips have messed up some migrations. I do wonder about that, like with critters that use magnetic north
The loose tags say
to navigate. Would that mess it up for migrating birds or sea turtles or something like
East
that?
101 north. What does the next one say on the
Anyway, I'm
map?
gonna go walk around a little bit more. I'll let them figure out the mapping thing here.
Okay, that one goes behind you,
But yeah.
probably.
And hello to you too, Subsonic Flight. Yeah. Good to have you here. Here, let me go get some more water. It does feel like it's hotter today than it has been, but still ridiculously cool for this time of year. And hazy. You can't really see the cliffs over there. You might not be able to see them at all over on the horizon. The clouds look super hazy. And you can just smell that wildfire smoke. It's irritating my nose a little bit. That's why I keep sneezing. Yeah. That's just normal summertime in the US now. Just got wildfire smoke all the time.
Thanks, big dog. Yeah, we're kind of blasting through that pretty quick.
I'm gonna try and adjust this shade tarp so it's not so saggy. But anyway, what's everybody up to in chat right now? How's your day been going? I hope it's been good. There you go, coconut cat. Like the Monty Python sketch.
Just go through it.
Look at what the wind has done to this poor tarp. We had a few tarps here. Even if the heat hasn't been bad, the wind has been. Wind's really done a number on some of these, and will continue to, most likely. In fact, I need to tamp that down a bit. We'll do this while we're streaming, just because I don't want that tarp to get completely torn. We're going to add some reinforcing bungee balls there. Here's one.
Yeah. Sorry, it sounds like I'm mad, but I was trying to speak really clearly.
Here's 3 more. So these are what we use to affix the tarps to these aluminum frames that we built out of conduit. Those corner pieces can be try and distribute the stress along here. There we go. Yeah. And there you go, solitary jerk, yeah.
So it's only the easting district. So 101.
I think it's an underrated Monty Python sketch. Confuse a cat.
49, 50 east, yeah. It's going to be 50 east, 101 north there.
Sometimes the purely absurdist ones are just some of the best.
But you don't need to put those 2 extra nails in because you can just line these 2 ends up.
I'll do one more, and we'll get some water. And Payne Haynes says a lot of digging happens on site, but has theorizing happened too? Or does that wait until afterwards when examining the results of the dig? So when you say theorizing, do you mean like trying to interpret what we see at the site? Because we're always doing that. We can't stop doing that. You know, every time we find a bone, we're trying to figure out what it is. Even if it's not easy to identify in the field, we're still trying to figure out, you know, what is this particular element? What does it mean? You know, is this a humerus? Is this a tibia? Is this a whatever? That's just something we're always doing. And often our field IDs turn out to be incorrect, but you know, you want to be able to figure out what the stuff is in the field if you can, because that informs you while you're digging it. You know, like how far is this particular bone gonna go? Do I expect to find a big trochanter over here? You know, maybe I should slow down when I'm getting to that part of it. That kind of thing. Yeah. But, so yeah, I don't know, we come up with provisional ideas in the field, we talk about them, but, you know, it's always super preliminary out here. We're not in a laboratory setting. We're out working in the heat, in the wind, in the bugs, in the dust, and everything else. You don't want to draw your conclusions while you're in the field, usually. Yeah, that makes sense. Let's check out that bone that Nick found. Look at that. It's starting to look more like a fibula to me, but I don't know. We'll see. Let's get out of the noise. And walk around for a little bit. As you can see, this is an active dig site. You know, my streaming here is auxiliary to our mission, you know? I'm here to dig, I'm here to collect specimens, I'm here to gather data. The streaming is just a bonus, you know? That's why I can afford to be here, is I do this for a living, and this is, you know, how I pay the bills. So if I couldn't stream, I couldn't be here. But our, you know, my prime directive here is to collect the fossils, and gather the data and everything. That's why we're out here. I don't know, so people were asking yesterday, like, oh, why doesn't he actually do any digging? It's like, well, I've been doing that all morning, and I will continue to do that after I put the camera down, after we raid out at the end of stream. You know, 2 hours and 15 minutes from now. But during this time, I'm here to introduce you to the site, introduce you to the crew, introduce you to these scientific concepts, answer your questions, give you a sense for what it's like to collect fossils in the field. What is it like to do field paleontology? That's the name of the game here. And I'm thrilled to be able to share it with you. And Mr. Friendly Boy says, are you in charge of this expedition? I am not, no. I'm a volunteer here. But yeah, so this is, our crew here is working with the Utah Geological Survey. And right now, I guess Ethan would be the one in charge. He actually works for the UGS as an intern currently. But yeah, our two crew chiefs here, Jim Kirkland and Don DeBlue, are both out of the quarry right now. Jim is on his way back to Salt Lake, and Don is on his way out here right now. So if we're lucky, Uncle Don might show up during today's stream. But he might be driving at a more leisurely pace and show up later, we'll see. But yeah, I've been working with this crew for 4 years now. So every summer I've been coming out from mid-July to early August. And that's the story this year too. Got out here July 16th, and we'll be heading back out around August 5th, 6th, that time. So then I'll be back home in my office and doing streams from there, like we do for much of the year. So yeah, Paynane says, thank you for streaming from the field. You bet. Yeah. Oh, and thank you, Murph, for that gift sub. I appreciate that. Yeah. Yeah. And Water and Poetry says, I'm waiting until he starts field work so I can complain about the lack of yapping. I'm an equal opportunity complainer. I appreciate that about you. Thank you, Water and Poetry. Yeah. And I appreciate you saying that, Casey Snowart. Casey says, always a joy to get to spend time in the field with you and the crew, Danny. Thanks for bringing us along. You bet. Yeah, it's a joy and a privilege. I said I was going to grab my water and I left it over there, so let's go get that. I am thirsty. And Mikey likes 52 months of support. Really appreciate you keeping me here online, Mikey likes. Good stuff. And Payne Haynes says, could you talk about iguanodonts? Yeah, so iguanodont with a T is, that's the family of dinosaurs, named after iguanodon. Not to be confused with Don DeBlue. Like I said, we'll hopefully be here in a few hours. But yeah, iguanodont dinosaurs are a really important group of beaked plant-eating dinosaurs from the late Jurassic to the Cretaceous period. They're some of the most successful dinosaurs in the Cretaceous, and they include the duck-billed dinosaurs. So duck-bills, hadrosaurs, are part of they're part of that big group of dinosaurs. Some of the earlier of which we have. So we'll talk about them in a minute. Let me get some more water. So iguanodonts look like this. I had the foresight to bring along an iguanodon patch to put on my field bag this year, on my camera bag. So this is the classic iguanodon. This is one of the most famous dinosaurs in the world. It's only the second dinosaur ever named, way back in 1825. So this year, 2025, actually marks the bicentennial of iguanodon. It's been 200 years since this dinosaur was first published in the scientific literature, since this dinosaur was named in a scientific journal. 1825, named by Gideon Mantell, one of the pioneering English paleontologists way back in the 19th century. Lots happened since then. Group and they've been found literally on all 7 continents. Europe, Asia, South, and on all 7. It does make me wonder if they've been found in India, because that was once a continent unto itself before it... so it basically split off from the side of Africa, and then it was cruising up along the ocean until it crashed into mainland. I don't know, something like 20 million years ago? Maybe longer. But anyway, I wonder if there's any iguanodonts from India. I'd have to think about that. Huh. I don't know if there are off the top of my head. Somebody in chat, look into that. But, yeah. Iguanodonts are really important. And the one that we have here, we have every indication is a new species. We're trying to figure out if we have 1 or 2 new species in there, because like I was saying yesterday, we seem to be getting 2 slightly different morphotypes in the quarry. So we've got a whole bunch of different bones from different individual animals, you know, different individual iguanodont dinosaurs that died here, left their bones here. And some of them, the hips look a little bit different. And Jim and Dawn are pretty well convinced, like, oh, this means it's a different species. And Karen is not so sure yet. But Karen's going to be leading this whole project for describing these critters. But let me get out the book again to show you. There we go. This is the book about the Cedar Mountain Formation. This just came out this summer, and you can now get hold of it. I'm in this book, and so is Selena, so is Ethan, so are Jim and Dawn, so is Nick, actually, in this photo in the back. There's us walking back from the quarry in 2022, I think. So, let's see. Brixton, Gastonia. There's some iguanodonts walking around in the background of this painting. Check them out. Yeah, really cool group of dinosaurs. Sometimes iguanodonts get kind of I don't know. Sometimes they're underappreciated in the sense that they're not necessarily the most flashy, spectacular dinosaurs. Like here's some right here, looking out across this flood. Iguanodonts there. Iguanodonts are sometimes called the cows of the Cretaceous. You know, they're herbivores. They walk around. They're not, like I said, not the most flashy of organisms, but they're common. They're herbivorous. They're ubiquitous. And there is Cedar orestes, aka Planocoxa, possibly, which is an iguanodont dinosaur from the Cedar Mountain. It's portrayed with a thumb spike there, like iguanodon has, but we don't actually have evidence either way. They may have had that, or they may not have. That's one of the things we're trying to figure out about our iguanodont dinosaur here, is did it have a thumb spike? And we're not sure yet. Although, those of you who were here last week when Karen was here, we had an element that looked kind of like a thumb claw, not a thumb spike. So if our identification is correct, and it is a thumb claw, it means, yep, no thumb spike, they had a thumb claw instead. But again, it's a field ID. It's provisional, it's preliminary. We don't know if further study will actually show that. For right now, it looks like a thumb claw, but we can't be certain as of yet. So anyway, iguanodonts, cool dinosaurs. Underappreciated, in my opinion. But yeah, let's see. And no iguanodontid dinosaurs in India. Talking about iguanodontids, but iguanodontians, the larger group that also includes. If we don't have hadrosaurs in India, then that answers our question. Yeah, no. Yeah, it's a little confusing. There's iguanodon, which is this dinosaur. There's iguanodontidae, which is the family that's named after this guy and includes this guy. And then there's iguanodontia in general, which is everything from Dryosaurus to Parasaurolophus, you know? It's a huge group that goes from the Jurassic all the way through the Cretaceous. Iguanodontia. So I would be kind of surprised if there's none from India, but I guess it might make sense. If that continent broke apart from the rest of Gondwana and started its northward journey before iguanodontians really became widespread, then we could have the only continent on Earth without any iguanodontians, which would be kind of wild. I've never thought about that yet. And no hadrosaurs yet. Interesting, Doris Magnus. Thanks for checking. No hadrosaurs from India. Wild. Yeah. Very cool. And CTWM says, is that book available on Amazon? It's not, no. So this book was actually self-published by Krista Sadler. She had an agreement with Indiana University Press, and I think she had some interest from some other book publishers she's worked with in the past, and all of them are like, no, we're not really doing big science books anymore with full color illustrations. We're just, we don't think that's the future, which really is lousy. So she had to do some fundraising and then basically self-publish the book, but you can get it at thisearthpress.com. Krista should be here in a few days, and we'll do a stream talking all about the book. But yeah, thisearthpress.com. And yeah, if you order, she might even sign it for you, like she did for me. I think she's been doing this for most, if not all of the books, which is pretty cool. Yeah. So, good stuff. And again, I'm in the book here. Let's find that. Where was that? It's toward the end. Oh, there's a quote from Ed Simpson there. when you look at the Cedar Mountain Formation, you can develop so many questions. There's so much going on in it that I can get my students really interested in dinosaurs, pond scum, trace fossils, mountain building, salt, etc. Cedar Mountain is pretty cool. Now, where am I in this? Could look in the index, but there we go. Yeah, there's my little quote there. One of the chapter headings. And let's see. Oh, there we go. Yeah. For instance, Danny Anduza says he's always been interested in dinosaurs. So here's a little paragraph about me. Yeah, he has a channel called Paleontologizing on Twitch, the video game streaming platform. He goes out into the field or works in the lab, and his interactive programs are very popular. I don't know about that, but... yeah. People ask questions and he answers in real time while he or other researchers are doing the work. Yeah. Good stuff. Anywho. And Proof KT says, I emailed Krista for a shipping quote to the UK last night. She seems wonderful. She is wonderful. Can't wait for you to meet her on stream. Talked you up for all the amazing advertising you and Jim were doing for her book yesterday, Danny. Thanks, Mothproof KT. That's excellent. And Golganek says, mine came signed. Very cool. That's awesome. Yeah. And we do have a good number of people watching right now. I appreciate everybody tuning in. Like I always say, the internet is a big place. You could be just about anywhere right now, but you're here with me, talking fossils, you know, doing field work. That's pretty special. So I appreciate everybody's time. And I'm eager to answer your questions. Or I feel so lucky that people find this sort of thing entertaining. Yeah. I think it's wonderful when a subject can be fascinating and entertaining, but also fulfilling, educational at the same time, you know? It's like you're eating your vegetables, but they also taste really good. You know? It tastes so good, and it's good for you, you know? Paleontology is like that. I'm pretty lucky. And Shappy says, you're living my childhood dream. I still get excited when I find a chunk of coral in my gravel. I know, isn't that cool? And that's probably back home, right? You're digging in gravel and then find fossil coral in there. That's a magical moment because you're realizing that you're seeing this thing that no living thing has seen in literally millions of years. But also it speaks to how the place that you live was very, very different millions of years ago. It kind of makes you see your home through a different lens, you know? There's the way that you know it today, as the place that you live and you're so familiar with, but it was very, very, very different hundreds of millions of years ago. And I like to think that the more you realize that throughout your daily life, gives you, it's like you're thinking long term like that. It kind of grounds you in a way. Trials or tribulations you might be going through in that moment seem a little bit smaller. And I think that's healthy. I think we need that as human beings. We need a dose of perspective. We need to not be so focused 100% on the here and now, getting overly worked up about whatever might be happening this instant. To realize that we're part of this unbroken chain of living things that goes back over 3 billion years. I think that's really cool, you know? It's cool to remember that, and it's cool to have a tangible reminder, like finding a fossil coral in the gravel outside your house. Anyhow. Imagining the dinosaur battles that happen here, I wonder if they had swords. Big time, big boy, most likely not, but they wouldn't have needed them, that's the thing. We as human beings need things like swords to fight each other hand to hand. You know, if we want to cleave off limbs and stuff. Dinosaurs didn't need that. You had carnivorous dinosaurs and herbivorous dinosaurs both, with all kinds of... I mean, just on the cover, you've got this big Utah raptor kicking over an iguanodont. Those claws to pin it down. And he's probably going to start eating this guy while he's still alive. Just like modern birds of prey do. Dinosaurs like Utah raptor are very close to the origin of birds. And birds of prey will do this even now. You know, if you see a hawk swoop down and catch a rabbit or something, it'll pin it down and just start ripping chunks out of it and eating it while its heart is still beating, you know, while that poor critter is still alive. And it's almost the same, almost exactly that. Almost certainly what these guys were doing too. That's what I meant to say. Yeah, this is a lovely tableau right here. You've got a snoozing dromaeosaur there. And there's some Gastonia in the background. Two of them are butting heads. Maybe over territory or mates or something. Maybe just for fun. Kind of like bighorn sheep do today. Similar idea. And you've got everybody walking around doing their thing. Yeah, there's a dinosaur battle for you. This is an intra-species one, same species. But yeah, no swords necessary on these guys. Or for these guys, you know, they've got swords on their bodies. Look at those big spikes, armor plates, and what Jim calls splates. It's like a cross between a spike and a plate. Like a big flattened spike. A splate. A plate-like spike. On Gastonia there. Super cool. Like, what an incredible animal. So Gastonia is just a little bit younger than the dinosaurs we're digging up here, so it's from a time horizon that's, you know, just a little bit closer to the present, maybe a few million. Yeah. Raptor right there. Big chunky dromaeosaur with those big sickle claws. What a cool critter. Yeah. So, good stuff. Get some more water. And I appreciate that, Flugfisk. Thank you for the kind words. Yeah. Gastonia handlebars. There you go, Goganek. Yeah. And yeah, Crimson Carnothoris. That is an early ornithomimosaur. One we talked about yesterday. Does anybody remember its name? I'll give you a hint. It was named in honor of paleontologist Ned Colbert. No, not Fred, RB42. Which dinosaur was named after Ned Colbert? Right there. There's its hind limb right there. Ned Colbertia, exactly, Gucci clone. Yes, indeed. Ned Colbertia. Which is an ornithomimosaur dinosaur. This is the one that was also, it's named after two people. It's named after paleontologist Ned Colbert, who was kind of a mentor to Jim. And it's also named after that, what was a 6-year-old kid, I think, who won that Discover Card contest after him. Justin Hoffman was his name. So it's Ned Colbertia, Justin Hoffman eye. It's, yeah. It's one of the the only dinosaurs I can think of who's named after two different unrelated people. There's some dinosaurs that are named after a family or after a couple or something like that. Yeah. But, actually, you know what? Jim has done that a few times. There's also Maiorapelta, named after Mygat and Moore, two surnames of two different people who worked in the quarry, I think. Yeah. More than one person. Maiasaura peeblesaurum is named after the who owned the land, I think, on which some of the original Maiasaura material was discovered. So Jack Horner named it after their family because they were, you know, so cool about, like, yeah, come here, dig on our land. You know, we want to support science. And as a result, they have a dinosaur named after them, which is really cool. By the way, anytime you hear aurum at the end of a species name, whether it's a dinosaur or a plant or an animal or a fungus or whatever, if you hear aurum at the end of the species name, that means it's named after a group of people, because that's, I guess, like a Latin or Greek plural. So yeah, if a dinosaur were named after me, it might be, you know, Dinosaurus Anduzai. But if it were named after you, meaning chat, it would be Dinosaurus chatorum, because it's named after a group of people, plural. So yeah. Scientists do love to name things. It's true, Christy, as we often say. Yeah. And RB42 says, I know a Justin Hoffman. I'm going to tell him you do that. Yeah. And you entered that Discover contest? That's super cool, Shrappy. I'm sorry you didn't win, but I think the result was pretty good. Jim was saying that that was the reason that he had a job for a year. Like, the company that he was working for, Dynamation, was not doing well. They were running low on funds, and so doing that thing where, you know, they got a sponsorship from Discover Card and held that contest, that was enough to buy Jim employment for another year, which is pretty cool. Yeah. And they found the quarry and it was named after them, says Paleo Ken. Is that right? The Peebles? Because it was on the Peebles Ranch, I think, yeah. Thanks, Ken. Yeah. And a quorum, yeah, there you go, Claire Bird. That's got to be the same root word, huh? Quorum, aurum. Yeah, nice. Spaceberry says, came for the dinosaurs, stayed for the scientific method. Yes, that's what I want, you know? Dinosaurs are such a great hook for getting people interested in science, interested in figuring things out about the natural world. And that was true for, I know, a bunch of people here in the quarry. They first got hooked on science because of dinosaurs, and some of them stayed, and some of them are now working on other things. Excuse me. God bless me. Yeah. And forum too. That makes a lot of sense, Christy. Yes. Yeah. Chatosaurolophus boggeri, says Crimson. Yeah, there you go. Oh, my gut and more. Oh, gotcha, Ken. Okay, cool. Yeah. Chatotitan hype trainee. Yeah. And it is fun. Naming conventions you can play around with them a lot, Christy. Yeah, it's good stuff. Yeah. Anyway, this wildfire smoke combined with all the yapping is really making me thirsty. Get some more water. But we'll get back into the quarry in a second. We'll also ask Nick about that bone, I think. See what's going on there. Yeah. And KN95 masks. Chaotic Time Traveler. I appreciate the thought, but that would make things... I would probably get heat stroke or something. Like, I would literally die, maybe. I wouldn't be able to wear a mask out here in this kind of heat. As cool as it is, it's only, what, like 92 or something? Excuse me. It would still be, yeah, way too hot. Yeah, let's go take a look at some of those bones. Now that it's gotten quiet in the quarry. Alright. Anything new and cool? Ooh, a vert? Nice.
Yeah, see, they're like little crappy, weathered bone bits.
We find a lot of those here.
That's why I wonder if they're coprolites, because they're just like
Oh, they could be from. They could have been digested, you mean?
pooped out,
Yeah.
because they look all weird and
Uh-huh.
punky.
Huh.
We were finding some like that
Uh-huh.
discovery site. Because they got like little. I mean, I'm not sure if it's really worth keeping, but yeah, they're kind of crappy.
Would you be able to do anything with that, geochemically?
I don't know. I'd have to think about it. I'm not even sure it's bone anymore because it looks like silicified or something.
Huh.
Pour some acid. Let's see if it's carbonate. It's weird.
Here's a little bit, Selena.
Yeah, like these little chunks. You break them open, they're like black on the inside, but they still have like the little perversion canals.
Uh-huh.
Oh,
Huh.
it's weird. So that's why I wonder if they're little like just pooped out bone bits.
Yeah, could be from a croc or something, potentially.
Yeah, something.
Yeah.
Not sure what you could do with them. I'd have to think about it.
Yeah. Oh, and Nick's getting ready to jacket this over here.
Just a little cap.
Yeah. Nice. So for those of you who are unfamiliar with this process, Nick is going to do a quick little gypsona cap on this. So for a larger bone, something that requires a bit more strength and rigidity, we'll use burlap soaked in plaster of Paris to make like a proper field jacket. But this is just a quick one. So we've got these medical bandages here, Gypsona brand. And yeah. Nick put some water into that scoop, so he'll just be dipping those bandages into there to activate them and then sticking them on over the top. He's put some wet paper towel, a separator, over it right now. He's measuring out how much he needs as I'm narrating for him. Nice. We're eager to take a look at that bone over there, too, the big one, when you're done with this.
This one?
Yeah. But,
I'll be done shortly.
yeah. It's cool to see this. And Stank in the chat says, does AI put all those tiny little bone fragments back together after you 3D scan everything?
No one's ever called me AI before.
No, Ethan does that. Yeah. And no, the second part of the question is, or does some genius eyeball it?
No one's ever called me that before.
But yeah.
Two first.
No, Ethan works for the UGS, and he'll be spending much of the rest of this year probably working on this, sticking fragments back together, opening up these jackets in the lab, that kind of thing. So it's amazing the amount of work we can generate from just 3 weeks out in the field. You know, it can take months or sometimes years to go through all the material that you get out in one field season. Is getting those strips. Nice. Sticking over the top like that. What?
I don't know.
Yeah, for a lot of this, we can tell it's a bone, but we don't know what exactly it is. You know, a lot of this is going to be Ethan in the lab figuring it out. Yeah. Getting some compliments on Ethan's dry sense of humor. So precise with that, Nick.
Hey man, got it down to a sweet science.
Yeah, I appreciate that.
It's easier to get it all, spread out before you lay it down. Otherwise, you just get bare fabric.
Right. You can get that, the texture peeking through.
Yeah.
So I made one of these earlier, a gypsona jacket for a rib that Fisher was working on over the past few days. I got that out this morning. And that's over here. Let me walk by you, Clayton. Let's see. Yeah, it's a weird looking one because the rock broke in a really weird way. But we've got a rib under there. It extends from here down to there. And this is super thin because there was just one giant chunk of rock that lifted off. But it'll be fine. And we've got two little plastic tubes right here to keep it from flexing. I put these to reinforce the jacket so it doesn't break along that axis. But these are little plastic tubes that are in the middle of the gypsona rolls. So try and use every part of the bison here, as it were. So the gypsona rolls look like this. Before you add water, and there's a little plastic tube on the inside. Sometimes we use those for things. And sometimes they just get thrown away, but yeah. The splint trick, exactly, Ken. Yeah, Ken says hi, by the way.
Hi, Ken.
Hope you're doing well, Ken. We miss you.
Seriously.
Yeah.
I haven't slept since you left.
No Ken, no Fisher, man?
Yeah.
That's rough.
When are you leaving, Nick?
Either Saturday or Sunday.
You're supposed to say never.
Yeah. I wish it was.
Gonna miss Nick, too? Shoot. Oh, well. Yeah.
It's always next year.
There's always next year. Yeah. And yeah, Fisher did have to go home. He's got a bunch of stuff to sort out before he moves to California, where I live, to go to grad school. So he's got his work cut out for him. I think classes start on, when was he saying? I forget. Sometime in August, like sooner rather than later. So, but yeah, that'll be cool.
Probably August.
Yeah. Okay. Yeah. So, yeah, Jim drove Fisher to the airport this morning. Hopefully he got into his flight. And then,
Thank you.
what do you call those? Meat discs?
Meat pucks.
Meat pucks.
Meat disc.
Better than rotten meat.
Made from genuine animal meat.
Better than rotten meat, I would hope.
Rotten meat, yeah.
Oh, it's beef jerky. Okay.
I think my nitrate income field probably increases exponentially. A lot of dried and canned meats.
Yep. Hot dogs. Yeah.
Mine's about the same. About level.
Sometimes, I just don't want to risk it.
Mm.
We were out with Lindsay's crew at NCSU, and some of the meat was going rotten. So sometimes it's best not to risk it.
Rotten meat is not ideal.
No.
It was still good. It's marginal. It's still good.
Anyhow, it is hot today. Somebody do the weather command real quick. What's the weather in, You could also do the weather for Green River, Utah. If we can compare that with Moab, because those are two towns that are both within 50 miles of here. Moab 99, nice. Green River 102, all right. Doesn't feel that hot here, but I'm not very good at this. What I need to do is actually bring my thermometer out to the quarry tomorrow, and yeah. Although, good chance we won't be streaming tomorrow. Good chance we won't be in the quarry. Yeah, we're going to be potentially visiting another crew from the Los Angeles. So working out here in the Cedar Mountain Formation. Our crew, so it's called the Dawn's Ridge site that Don DeBlue found years and years ago. And they might have the same animal that we have here. We're not totally sure. We suspect that their site might be a little bit younger than this, or it could be the same age. We don't know. But yeah. Luis Chiappe's crew. I don't know if Luis will be out there, but his crew will be out there. We'll go say hi. What do they call that again? It's like a nautical term. I know it's in Melville's Moby Dick. When two ships meet out at sea and everybody just hangs out for a while and they exchange letters and stuff like that, news from home, all that kind of thing. What's it called? Somebody in chat knows the term, I'm sure. What is that? And Ken says it was about 100 yesterday when I left. Shoot. Darn. Yeah. Didn't realize it was that hot. No, it's not a parlay. One of the chapter headings, one of the chapter titles is I think this term. I forget what it was. It's been too long since I've read that book. Let's see. Let's see. What is that? Oh, the GAM, right? Is it called a GAM? I think that's it. Yeah. Yeah, that's it. That's it, Lordy. Yeah, GAM. I just looked it up in the list of chapters. It's funny. That's less evocative than what I seem to recall. It's like that could be just about anything. Anyway, it's going to be like that, you know. It's always fun running into another field crew and just kind of shooting the breeze with them, being like, hey, what are you working on? Show us the fossils you've got. What's the weather been like? You know, it's just fun catching up. You meet new people, you run into old friends. This would happen to us all the time when I was working in the Hell Creek Formation in Montana. So we'd be out there in Garfield County or in Valley County, and then we'd go into town and like, hey, there's another group of paleontologists. There's Greg Wilson and Dave DeMar from University of Washington. Ask them what they're up to and hang out and have lunch together. And, what's the latest gossip about what's going on at other museums and who's retiring, who's being hired, who's died, you know, stuff like that. It's always fun. Yeah. Like, oh, did you hear about this thing in the news? Like, oh yeah, they finally got that paper published. What about this one? Oh, I don't know how that got through review. That kind of thing. It's always fun, especially when, you know, you're out in the middle of the desert with of often like 20 or fewer people for months on end. Other people, and, you know, be able to interact with folks that are outside of your immediate group is that sounds like the most mundane thing in the world, but when you're out in the field, it's something you look forward to, you know. Yeah. And yeah, at a GAM on the regular. There you go, Midi Moonstorm. Yeah. And let's see. My pop would call that having a gab, says Payne Haynes. Interesting. Okay. Nice. But yeah. It's funny, we've got some members in the crew who hate that book, Moby Dick. It's one of my favorite books. And I brought it out here and I haven't had a lot of time for reading, so I haven't gotten to that one yet. But often I'll read that in the field, and it's fun, just like the number of parallels between that and fieldwork. And there's a lot of discussion of bones and anatomy and stuff, because, you know, they're out there killing and slaughtering those poor whales. But also there's like a sense of camaraderie among the crew. There's, you know, a lot of stuff to relate to there. Just being away from home for a long time with the same group of people, and everybody's different personality quirks and stuff. And then you meet up with other crews for a gam, and, you know. Also just a lot of kind of philosophical ruminations, thinking about, you know, what does this all mean? We tend to do a lot of that in the field, you know? There's a lot of time for action, conversation, and kind of deep thought. Out here in the middle of the desert, there's not a whole lot else going on, you know, aside from our work and our discussions. Yeah, I don't know. I think that's one of the reasons why I like that book so much, is it reminds me of fieldwork. Yeah. And hello, Scient Streams. Belinda, I need to give you a call sometime soon about TwitchCon. Shoot. I've been getting emails and stuff, and I need to check in with you. And, yeah. Ask some advice on a few things, and yeah. But I'm really looking forward to TwitchCon. Anybody in chat going to TwitchCon this year? Any plans to be in San Diego from October 17th to 19th, 2025? That's where I'll be. Not wait. Yeah. But yeah, and you chase a rare find, says always. Yes, indeed. And a thing for paleontologists. Augsburger, I'm not. Augsburg, I can't say I've ever heard of that, so I don't know. But there are many different kinds of paleontologists, and some of them do a lot of coding. And yeah, I don't know. That might mean something to some of my colleagues here. I'm not sure. Yeah. And we may be very busy. I think I might be too. Too. God. Smoke in here. Yeah. But yeah. And thank you, Claire, Solitary, Lenina. Gracias. Sketchy tracks, yeah. Let's get some more water. But anyhow, is anybody here planning to go to TwitchCon? I'll see if maybe I can stream from there. I'd like to have at least one day that I could just walk around with Velia for much of the day, my Velociraptor. So we'll see. But yeah. Let's see. Is the wildfire still active, says Cosmological Kev? There's a bunch of different wildfires, so we're kind of getting it on all sides. Yeah, I don't know which one in particular this smoke is coming from. I don't know if it's somewhere in Utah, or if it's just across the border in Colorado, or where. But yeah, there's several simultaneous wildfires going on at present. And yeah. In fact, several members of our crew went out to the gas station last night, you know, which is only like 25 miles away or whatever. And they saw a wildfire from the road, and they said it was crazy looking. They're like, yeah, it looked like something out of, you know, Lord of the Rings, or, you know, it's like, there's Mordor over there. Especially at night, just seeing like the hillside ablaze. They were looking at it through binoculars, and it was a sight to behold, apparently. I don't know if this smoke is from that or from a different one, but the point is there's a lot of wildfires going on right now. And we get the smoke here, but we don't have to worry about fire, not in this valley, because there's just nothing to burn, you know? You're not going to have fire spread in an area where there's just rocks and dust and dirt and more rocks. There's not a whole lot of vegetation here, especially over near camp. Even if that hillside were to go up over there, we'd be safe in camp because there's nothing to burn. So, yeah. That's one bit of solace here. And the west is totally on fire. This is midi-moonstorm. Yeah. That's kind of the new normal here, you know? There's, with climate change and with this area continuing to dry out, as you get droughts throughout a lot of these western U.S. states, yeah, wildfires are becoming more and more common. And then you go up north into Canada, and it's a year-round thing, you know? They've got wildfires not just during the summer, but during the winter, too. And it's distressing, you know? It's not good. It's both a cause of climate change. Like, it results from the climate changing, drying out, things getting hotter. But it also helps speed up climate change just because you have entire landscapes that burn up and then put a ton of carbon into the atmosphere, and it accelerates the process. So it's no bueno. It's really not good. And it's interesting to think about that happening today, and also look back into the rock record, what we see preserved. You know, you get the climate constantly changing throughout Earth history. You know, really the only constant on our planet is change. So you get these times when clearly it was very, very wet for a long time, and you get things like kaolinites that show that, like, the ground was just super saturated. And then you get periods where it's a lot drier. We can sort of find proxies to figure out what the general average temperature was on Earth at given times in Earth history. And we can kind of track that over time. It used to be really, really fuzzy, really loosey-goosey, but we've started to really nail that down, have a better sense for, you know, what the climate has looked like at different times in Earth history. But the idea that I want to leave you with is that, you know, despite the fact that Earth's climate has always changed, we should be really worried about climate change today. You shouldn't brush it off and go, oh, you know, hasn't the climate always changed? Pretty much never as fast as it is right now. That's the scary thing, is it's not happening over the course of millions of years. It's happening over the course of, like, human lifetimes, you know? Just a couple centuries. So quick that it, like, wouldn't even be recorded in the rock record. Just blink of an eye. And that's the truly troubling thing. Because we see big shifts in Earth climate, but normally they take a long time to happen. What we've got going nowadays is rapid to the point of, I don't know, it's very distressing. Yeah. Speed running the Permian extinction. Exactly, Charlie's Dragon, yeah. And that's nuts. Nice church. Shoot. Zombie or root fires? Yowza. Oof. Anywho, maybe we'll ask Selena about that real quick. What are some ways of determining, you know, what the climate was at different times in Earth history? How do you track that kind of thing? Yeah. There you go. We got a question for you, Selena, if you got a minute.
Try my best to answer.
Yeah, I appreciate it. We were talking a little bit about Earth climate, how it changes, and how do you track that sort of thing through the rock record?
So we have these things. So recent paleoclimate, you could do stuff like ice cores, or even like tree core, like core in a tree, and looking at like the growth rings on trees, and you can relate that to like precipitation and temperature and stuff.
And when we say recent, that's like within the last couple 100,000 years or something like
that. Yeah, to like the last ice age. Like the oldest ice core, I think, is like maybe 2 million years at the oldest, which is pretty cool. That's pretty old.
It goes back a long way for ice.
But beyond that, we have these things called proxies, which is just a substitute, right? So
kind of an oblique way for figuring it out if you don't have the direct evidence in front of your nose.
So you can't go out back in time, put a thermometer out, and be like, it is this degrees. You need proxies. Sometimes those proxies are chemical, so you like grind up this rock, analyze it for something, be it isotopes or trace elements or whatever, and then you use that. You use modern relationships to calculate say, temperature, or
Sure.
CO2, or mean annual precipitation.
Yeah, yeah.
So that's how we look at climate in the deep past, is looking at proxies.
Mm-hmm.
So a lot of it, there are other proxies that are not chemical. So, for example, stomatal index proxy is a way to calculate CO2.
Looking at leaves. Yeah.
Look at CO2 in the ancient rock record.
Yeah.
So the number of stomata, which are like
The pores.
the
almost,
pores
yeah.
on that
Yeah.
open and close so that it can breathe
Uh-huh.
CO2 in.
So that number correlates to what
that
the
number-
carbon dioxide.
So the more
Okay.
CO2 in the atmosphere, the less number of stomata
Gotcha,
you have
yeah.
on the underside of the leaf.
Uh-huh.
This is like species specific, I think, like
Uh-huh.
type of plant specific. So you
Sure.
have like a series of modern types of plants, say like ginkgos,
Uh-huh.
and so you have a comparison in the past.
Mm-hmm.
And if you have really good preserved cuticle, which is like the thin waxy layer on the bottom of the leaves,
Mm-hmm.
you can preserve them. And so you put them under a thin section, and then you
Uh-huh.
just like count. You like point count them.
Neat.
The Smithsonian has like a cool kind of like citizen science crowdfunded. I don't know if it's still going. I think it's still going, where they have these and
Uh-huh.
people can log in. It'll come to me in like 5 minutes. But yeah, if you check out Smithsonian Stomatal Index or Smithsonian Institute CO2 Citizen Science, it'll probably pop up.
Uh-huh.
Why is it not popping in my brain? It'll pop in my brain in a little bit. Had a whole conversation with him like
We'll figure it out. Yeah.
a few months ago. So yeah, that's a different proxy. So that's a proxy that's not chemical, but it's like fossil, I guess. It's a
Right.
fossil
Yeah.
proxy.
Yeah.
There are even some proxies, so there are some papers out there like crocodiles only exist between certain temperature ranges.
Uh-huh.
And so, if you find a crocodile fossil in a particular area, you know that the temperature range must be between like here and here.
Sure,
It couldn't be
okay.
less than, I can't remember specific temperature, but like less than, that area couldn't be less than, I don't know, say like 15 degrees Celsius or
Yeah,
something
yeah.
like that. So,
Uh-huh.
so there's a number of different ways you could do proxies.
Sure.
Or do estimate climate in the past. That's one way. Then the other main way is by modeling climate, which I'm not very good. Like that's not something that I do. So
Uh-huh.
I know it well enough, but not very well. So, and that's looking at the current modern climate system. Kind of what connects to what, right? CO2 connects to temperature. Temperature connects to precipitation rate. And coming up with equations that explain all of that. And then rather than forecasting, you kind of like backcast.
Sure. Yeah. Yeah.
So
Cool.
there's a number of different climate models that, calculate temperature or CO2 in the past.
Yeah. Yeah.
And they're getting more and more sophisticated, more and more statistical, and things like that. So,
Yeah.
and the best ones are proxy model systems where they integrate together. So
Nice.
they use proxy, or they do inverse modeling, where like the modeling happens and spits out the isotope value, say, of a carbonate nodule.
Uh-huh.
And so you go check
And
the
see.
carbonate nodule have the same range of oxygen isotopic composition that the model predicted. If
Gotcha.
so,
You could check your
then,
work, basically.
Yeah, it kind of, and so it loops in on itself.
Uh-huh.
Get probably Bayesian related again.
Yeah. Yeah.
But because it's estimate, that is a way to figure out the priors, and then you run the model.
Yeah.
Probably gonna explain it back like really poorly, and my colleagues who do this for real are like, Selena, you're slaughtered.
This is more than I can do, so I appreciate
So,
it.
so that's another way to do
Yeah.
it, and so like, that's kind of like a, ideal, I think, is like these proxy model
Uh-huh.
integrated systems.
Nice.
So,
Yeah.
so that's kind of how we do it.
Very cool. Now, to broaden out a little bit from there, why is it important to understand how Earth's climate has changed over the history of life on Earth?
Yeah.
Like, what kind of perspective does this give us?
So it gives a perspective on the modern climate system and how it's changing. For most of Earth's history, we were in a greenhouse state. So,
Yeah,
and a greenhouse state means there's not permanent ice caps.
Yeah.
Currently we're in an ice house, but we're rapidly fluctuating to a non-ice house state, like a transitional state is what a lot of paleoclimate scientists call it. It's like a transitional state. So understanding those transitional states and like how the Earth operates, Earth sensitivity, for example, in a greenhouse climate is important to understand kind of like where we're going. This experiment for us in the past. We've gone through super greenhouse events, like the mid-Cretaceous.
When there's just basically no ice on Earth during certain times,
no permanent ice caps. The Paleocene, Eocene thermal maximum, where there were like crocodiles up in the,
up in Alaska.
Up in Alaska. They're. So understand, the Earth has made this experiment for us. And so like if we can go back and understand those the climate system, then we can hopefully help predict where we're going in the future.
Right, yeah. Cool.
So, and the Earth is it's a pretty amazing system. It balances itself out. So things will work out fine for the Earth eventually.
Maybe not so much for us, or for human civilization.
Much for us. So.
Our planet will still be here, but it might.
Yeah, it's not going to explode or anything like that, but it might not be great for the animals that are living here.
Right.
So. So understanding that how climate has affected like biota over time, how these major climate perturbations have affected distribution of organisms. Extinction, both local and global, is important. So that's why, when you're like, oh, well, who gives a crap about whether or not it rained this amount per year in the middle of the Cretaceous? It's like, well, we're rapidly headed towards the Cretaceous, so might be good to figure out what happens before and after. Like, what could we expect?
Right. Get ready for crocodiles up in Alaska again,
And more intense precipitation is one of those things that has been that we have found looking at climate proxies through greenhouse events is intense precipitation, more intense precipitation, greater silicate weathering. Silicates are rocks. These are rocks. These are silicate rocks. They're silica-based. You weather them, silicate weathering. That's Earth's natural process of getting rid of CO2 from the atmosphere. But to do that, you need like lots of rain. Rain helps and accelerates chemical weathering. So we have ideas of what's going to happen, but you don't know that. We know that from Earth's climate record. So past climate record. So
cool.
So understanding those intricacies is kind of why it's important to figure those things out.
Sure. Yeah. Cool. Well, thanks for taking a minute to talk to us. Appreciate it. Yeah. Cool. So I hope that makes sense.
We're talking about cool little features on petrified wood.
Oh yeah.
And you also mentioned dendrochronology.
Oh, neat. Here, let me pass that. Good catch.
Oh yeah, this one has some good wood, like good rings in it. I don't know. Can you see it?
Yeah. Here, I can even get out the magnifying glass. Give me a sec. I've got a special one for the camera.
Oh, nice.
There we go. Yeah. Check that out there. Yeah. Nice. So what does that tell you?
So Dave Staley is going to kill me. So I'll probably slaughter this. He's our dendrochronologist at the University of Arkansas.
Very cool. That's
yeah. So you can look at early wood, the width of early wood and late wood, and I'm not sure which one what. But you can use it to calculate things like precipitation rate over time.
Right. So it can give you a proxy for climate. Again, like we were talking about.
It gives you a climate for proxy. And it gives you climate for like, what is it, the dryness, some sort of dryness index. I don't remember all of them. Do you know more than I do?
No, I think that's right. Yeah, you can get different thin and thicknesses, will just give you an idea of like
how much the tree is growing during the wet season, based on how wet it is.
How old the tree is.
Yeah. So there's which will tell you how old things are, like how old the wood is, and you can, basically date the inner and the outer part, so you bracket the specific age of the wood. Lengths of the early wood and late wood. The early wood is which ones? The late wood is compact, I think, and the early wood is like more porous, so it's thicker.
Huh.
So those are the lines are like the early wood, I think. No, the late wood.
Also,
late wood.
like depending on different types of wood and stuff, you can see like events, like fires.
Yeah, yeah.
stuff
You can
like
get
that.
scars from forest fires and stuff
Or-
like
or
that.
certain
And
type of bugs or like beetles
Yeah.
or burrows.
Yeah, yeah.
So
you can
So-
tell when there were big droughts and stuff. Talking about stuff in the modern, like we can actually correlate that to like almanacs and stuff like that. You know, figure out, oh, there was a really big drought this year, and then shoot, you've got a super thin ring in the tree from when it just wasn't growing because there was no water during that
Yeah.
time.
So they have records back to like the 1500s or even older
Yeah.
prehistoric times. Like there's great records from Ireland, from bogwood.
Oh, cool.
That,
Yeah.
like old oak trees that were in the bog.
Uh-huh.
And so you can have climate records that far back.
Yeah, yeah.
The bog. Yes. So,
Pretty
yeah.
neat. So we can use those same principles on
You
wood
can use
from
the same
Cretaceous.
principles as wood from the Cretaceous.
Yeah.
Yeah. I mean, you're not going to get what specific year. It's not going to be like 1100, right?
Uh-huh.
It's just going to give you a snapshot year,
Yep.
a series of years
Uh-huh.
from the Cretaceous.
And if you see like, you know, crazy differences in the rings, like you can tell this is a super seasonal climate.
Yeah, yeah,
really dry
exactly.
during the
Seasonal
dry season.
yeah,
Yeah,
you can look
yeah.
into that. Yeah,
Mhm.
exactly.
Pretty neat.
So,
Yeah.
this is a nice piece. Where'd you get that one?
literally right outside of
Cool.
the tent.
There's a neat
Cool.
little knot right there.
Oh, that's neat. Can we see?
See the little knot?
Yeah, look at that. It's so cool to hold something like that in your hands and go, yeah,
There's
this
a
is 130
big
plus million years
log
old.
up in the Natarita that
Yeah.
we just passed by. There's shards coming out.
Yeah.
Nice piece. Here, Nick. Oh, bad
Good
chance.
catch.
Sorry.
Cool.
Right.
Thanks, guys. That's awesome. Yeah. So again, this to try and integrate this chat. I think this. There's so many different ways that you can approach problems in paleontology. If you're trying to figure out what this ancient ecosystem was like, there's so many different ways that you can study that. You know, you can look at the dinosaurs, like people like me and Ethan do. You can look at the trees. You can look at the turtles. You can look at the rocks. You can look at all these different bits of data that we get, and they all hopefully come together as a coherent picture. Different pieces of a puzzle that you just slot together, and there it is, you know? And it takes a tremendous amount of work, a lot of different kinds of expertise, a lot of different kinds of people, a lot of different kinds of analysis. But at the end of the day, you know, we're all on the same team. We're all trying to figure out the same thing. What was this ancient ecosystem like? What is the story of the development of life on Earth? And you'll get competing ideas, you'll get scientists who butt heads, you'll get disagreements, squabbles. There are stories of fistfights happening at scientific conferences. Scientists usually. Hey, we are all on the same team. We're all using the scientific method to test ideas and try and figure out what's true and what's not. And, you know, being a small part of this is such an honor, you know? I'd encourage anybody who's fascinated by this kind of thing, see if you can. There are, even if you don't end up being a scientist, if you don't end up in academia, you know, that's not the only way to do science. There are citizen science projects, community science projects, where, like Selena was talking about, you can help contribute to research from the comfort of your, you know, computer desk. There are ways to do this that don't require, you know, a lifetime's commitment. And I think the more people who get involved with that, the better. Because not only are people learning new things, and not only are we making scientific discoveries, but people in the general public are learning the value of and the importance of science. That's a big part of what I'm trying to do here with this channel, and I'm continuously humbled by the amount of support we get, and enthusiasm and kind words, and, you know, jokes and japes and snarky remarks too. It is Twitch after all. But yeah. And NPC Upvote says, is AI helping paleontology? If so, how? No, it's not. At least, not really. Not like LLMs, you know, like what most people think of as like AI, chat, GPT, and all that. It's definitely creating problems for other branches of science, but in paleontology, I don't know, I feel like it's kind of irrelevant. There are ways of analyzing data using computer algorithms. I don't know if you could call it AI, but like crunching large data sets and stuff like that. But, you know, it's not AI in like the overhyped sense that, you know, the stuff that you hear about in the news every day, and, you know, those hucksters in Silicon Valley. Yeah, I don't know. There might be new methods coming out of this. You hear whispers of that kind of thing, but for the most part, it seems like people have a tool and they're in search of and not really coming up with anything quite yet. I suspect it'll continue in that direction, but I don't know. I don't buy into this crazy AI hype. That's a bubble just waiting to burst. And it's going to take a big chunk of the U.S. economy with it, the world economy with it when it does. That's my 2 cents. Yeah. Anywho. And the Raven says it's more of an algorithm than AI. Yes, it's an inaccurate term for it. There you go. Yeah. Yeah. Let's see. Scrolling. That's right. We don't need AI in the dig site. We have Ethan Payne Haynes. Exactly. Yeah. Anywho, yeah. This actually gets into something. I won't name names here. But, there is a local fossil site here in Utah, and they had a little like gift shop with some merchandise, and they had what was supposed to be one of Jim's dinosaurs on a postcard, and it was AI generated, so it's like an LLM, you know, like image generating thing. And Jim flipped his lid when he saw it. He's like, "What in the world is this? This is absolute dog water. This is the worst kind of garbage." Because it was supposed to be Gastonia, you know, his Polycanthine ankylosaur, so big spiky boy, very cool dinosaur. We know what it looked like. We have really good fossils of it. It's got a very distinctive look, and this was not that. It was like a weird plasticky, like, I think Jim said it looked like a scaly porcupine with like a stegosaur head on it, like something like that. I don't know. When I think of AI in paleontology, that's generally what I think. The worst kind of lazy slop, and that's honestly what I think of when people talk about all the hype around AI. It's just like if you're using this sort of thing on the regular in your job to like do your work for you, like people must expect really lousy work from you. Just my opinion. Like, it's garbage. It doesn't work well. Use your brain. We're human beings. That's what we're for. That's what we're good at. You know? Don't discard your humanity, you know, in favor of laziness, you know? Ugh. Anyway, end of soapbox. That's my 2 cents there. Let's talk about science. Yeah. Yeah. And there you go, moth-proof. Yes, indeed. Yeah. Anywho. And Doris Magnus says for paleoart or analyzing huge data sets. I mean, analyzing huge data sets, that's something I've been doing with computers for a long time, and there's algorithms for that. I don't know if we could call them AI, but for art, it's like universally terrible, especially when it's something like, you know, dinosaurs. When you're doing paleo art, the whole point is that you're synthesizing information that's very arcane, you know? It's like, here you've got, say we've got our dinosaur from here, our iguanodont. And we want to figure out, you know, what did this animal look like? We want to do an illustration of it. That's based on very, very specific information that is not out there on the internet. It is not something that an LLM is going to, compile information for and then spit out a result. You're just going to end up with garbage. When you're doing paleoart to reconstruct an extinct creature, you're actually going and you're looking at the bones. You're figuring out their proportions. You're figuring out how they'd be oriented. And you're using clues from other kinds of dinosaur that we already know about, in the case of like this iguanodont. And you're making educated guesses. Like, every decision that you make should have a reason behind it, Like, you make the snout 15% shorter than it is on Planet Coxa. Well, why is that? Well, you might look at what the ancestor of this dinosaur might be, something like Camptosaurus. What's its skull? Well, let's make it kind of intermediate between this later one and this earlier one. Kind of find a happy medium there. Maybe this is a wetter environment than you have for either of those dinosaurs this new one lived in. Well, maybe the toes are going to be a little bit longer, so they're going to spread out a little bit further so it won't sink down into the mud when it's walking around. That's a guess, but it's an educated guess. And this is the sort of thing that a computer can't do, Every single one of those is a very human decision that's based on actual information, and it needs human discretion to figure that out. You'll never get that with a glorified autocomplete like an LLM, It's not how these things work. That's a fundamental misunderstanding of what LLMs are all about, large language models. But yeah. Says the VFX artists are very good at finding flaws in so-called AI masterpieces. There you go. Yeah. Yeah. Oh, and we got a great question from Forced Penguin, it looks like. We'll go down to the quarry in a minute and say hello to Uncle Don, because he just arrived. But first, question from Forced Penguin. The climate discussion made me wonder, do wind speed, water play a role in Again, these are computer models that do this. Like one of the ways that computer models are actually used for a predictive means, like it actually works too, weather prediction, is you have these complex models that you set up. I'm just going to be, I'm going to butcher this because I'm not a meteorologist. But as I understand it, you've got these complex models and that the landscape looks like. Here's certain areas that are heat islands. These are ones that absorb heat. You've got waterways in this area. And then you kind of like run the model and see what happens to predict the weather in areas like that. And then you can test that against what actually happens and refine your model further. With that sort of thing in the Cretaceous, it's just not possible. We've got a pretty good idea of where the different continents were at certain times, but we don't necessarily know when there would be land bridges in certain areas. To like know where you could have ocean currents going through, or maybe the ocean can't move through. That area is land at this moment. Hazy. Particular, like, wind primary direction, and what are the oceanic currents? That's my understanding. I'm not a paleoclimatologist either. But great question. Yeah. Anywho. And Subsonic Flight says, are power tools frequent guests these days, or just overburdened so hard here? We have been using the rotary hammers more often here, more frequently. And that's kind of a result of just them being super easy to use. So as you can see, we've moved a ton of rock this year. All of this debris right here is stuff that we've moved this season. All the way down to there, all the way up to here. You can tell that this is fresh because it hasn't been ground down to dust yet. It hasn't eroded down to the point where it's just lush. So, here. This is from last year. You can tell because it's just eroded down to dust like that. So this stuff is not fresh. This is a pile that we made last year. This stuff is fresh. This is from yesterday. All of this rock here. So all of this through here, all the way down here, this is all from the past 2 weeks. Basically 11 days of work so far. 11, 12, 13, whatever it is. Whatever the stream title says. It's the number of days we've been working in the quarry. So, that's a lot of rock that we've moved thus far. And much of this was broken up by those rotary hammers. Those are battery operated, which is really cool. It means that we can just kind of break those out whenever we want and just go to town on the rock. It's a new development this year. Ethan brought those, the rotary hammers. You can tell he's very proud of them, as he should be. Last year, if we wanted to move overburden, it was picks and shovels, and then the jackhammer over here. Jackhammer is something that we would only really use in the morning when it's really cool out. And we'd have to fire up this generator, put gas in it, make sure the spark plug's working, all that jazz. Run an extension cord out. It was a huge undertaking. So like, every time we want to use the jackhammer, there's a lot of steps that you got to go through first. And so, you know, we'd say, okay, we're going to jackham for 2 hours tomorrow morning. Let's get everything set up for that. You do it, and then it's done. This year, we don't have to do that whole rigmarole. We can just use the rotary hammers. It's a lot quicker, and we can kind of start and stop whenever we want. You know, just pick it up and go. It's on demand in a way that the generator and the jackhammer really aren't. Does that make sense? Yeah. So that's why we've been hearing the rotary hammer during streams, is because, yeah, it's on demand whenever we want. So, yeah. Hope that makes sense. And But anyhow, let me get some more water, and then we'll go say hi to Uncle Don. Ask him how things are back in civilization. Ah. All right. And right tool for the job works best all around. I agree, Dan the PC man. Yeah.
I don't think I saw any blue tarps.
Who's this very clean-looking gentleman?
I know, you know, that's brave.
How you doing, Don? It's good to see you.
The outside world.
Yeah.
I bring greetings. Don't go. There's no good news from the outside world.
Well, shoot, I'm glad we're here.
Stay in our bubble. Falling bubble, good. Outside world, bad. There's people there.
Uh-huh.
Yeah, not good.
How's your finger doing?
It's coming along.
Yeah.
It's not still great. I've just kind of loosely wrapped. So
Nice. Okay.
I was showing these guys earlier, so
Oh, okay.
I can show you later. But
Yeah. Probably not.
We don't want to
we want to do on camera, though. Yeah, people are eating.
right.
Yeah.
Crying.
Who knows? So.
Yeah. But anyway, it's good to have you back, Don.
Sure.
Yeah.
Oh, there's gloves over there too. Damn. I can't believe Jim is.
It's because we've been
Let you
doing
guys
chemo
get
strap
away.
for the last few
Well, then
days.
you can you can
Okay,
wear
no
for
gloves
that.
allowed, Glenn.
What?
No gloves allowed.
We can wear gloves on your.
No gloves.
Are you a lefty or a righty?
I'm a righty.
We can wear gloves on our ears.
So you can wear gloves on
You are.
your. Well, which one are you? Like,
Yeah. This is a running theme in the quarry. Don's been doing this working in Doling's Bowl for 20 plus years, doing field work for like 40. Yeah, Don's got a very specific way of doing things, and we listen when he's got something to say. And if he says no gloves on the quarry, no gloves on the quarry, you know? Yeah. This is, different crews have different ways of doing things. And, yeah, for Don, it's kind of a my house, my rules sort of thing. And you know what? That's cool. Yeah. But yeah, and his finger is still attached. Absolutely. Yeah. And Claire Burr. Don does have enough experience to know exactly Charlie's Dragon, yeah. And yeah, I don't know. I know you're joking, talking about chainmail gloves, but yeah. If we were doing that, then we'd be, destroying all the bones. You know, sometimes field work requires a bit of a blood sacrifice there, and sometimes you get a little bit hurt in the field, and as long as it's not too bad, then as long as you can survive to dig another day, that's not the worst, Yeah. Yeah. And it was the pressure that did it, Charlie's Dragon, actually. Yeah, good point. Yeah. I was going to grab my water, because I'm out in the other bottle. There we go. Oh, this one's almost out, too. Shoot. Put some more water in here. Here, do this with 2 hands.
It's shaped like it's a horn shape. I mean, it definitely was a tapering thing in the sharp tip. And it had cortex on every surface with cortex, so it's complete whatever it is. Really weird. Maybe it's
Oh, there we go. Somebody had a question earlier, and it was like, how did paleontologists back in the Wild West days manage to bring enough water to their field sites to use for plaster and drinking and everything else? And from what I understand, the answer is way back then, 150 years ago or so, there were a lot more local sources of water. So if you just had a horse-drawn wagon or something as you're going out to the field, it'd take a lot longer to go into town and get water from, where the town is. But there were a lot more springs and creeks and rivers and stuff nearby that you could drink out of without getting sick. We don't have that nowadays. It's like more intensive agriculture, and the pollution and stuff makes it so that a lot of our local waterways that you find are not safe to drink out of. So we have to truck. We've got big plastic to use. 5 days, something like that. Have somebody take a vehicle into town and fill those up from the municipal water supply, and then we'll have enough water here. 8-gallon drum. We can put whenever we want. But yeah, water is a thing that we go through a lot of out here. Not just for drinking, and not really for bathing, but for a little bit for cooking, a little bit for doing dishes, and a lot for working in the quarry. So sometimes we'll use water in order to help break up this mudstone a little bit when it's too hard. It kind of resaturates with water when you put it on there, and it'll start to crack and kind of turn back into the mud that it came from. But also we use a lot of water when we're making plaster. So when we're constructing plaster jackets, You know, you put the powdered plaster of Paris into some water, and you end up using a lot of water doing that. So water is one of those essential things that we could not do this work without, obviously. I hope that makes sense. This is not a low water use kind of enterprise. We go through a lot of H2O out here. As you can tell from my keep taking water breaks. Yeah. And Flugfisk says you need to make a documentary about this on Netflix. I would love to. Shoot. I would love to be able to do that kind of thing. Maybe someday. But for right now, you know, streaming live from the field, and then all the VODs go up on YouTube and watch the whole back catalog if you'd like to. On the Paleontologizing YouTube page. I'd like this to be a resource for people if they want to figure out what fieldwork is actually like. This should give you kind of a taste for that. Yeah, I like to think it's a cool resource. But, yeah. Excuse me. I thought I was going to get to be in the new Walking with Dinosaurs that just came out. That was filmed 2 years ago over at Laurie's site. Just a couple miles that way, over there over that ridge. I did not get to be part of that because the BBC, the British Broadcasting Corporation, made everybody, I guess, sign a contract saying that there would be no other media at the site whatsoever. And apparently that also included people doing science outreach on Twitch. So I was not allowed to be there. I could have gone there and maybe been in the documentary and just not streamed for 3 weeks, but I gotta make a living, you know? This is how I pay the bills. I can't not work for 3 weeks. Not when I've got a choice, you know? So, yeah, so I wasn't in that, but I'll be back at that site now. I guess the contract is expired now that the documentary is finally aired. So I'll be able to go out there in September. So with any luck, I'll be out there working at Laurie's site with Josh Lively and crew from the Utah State University Eastern Prehistoric Museum. That's going to be a lot of fun. Some of you already met Josh Lively in our streams from St. George. That was part 1, was when Josh was there. And yeah, that was a lot of fun. Josh is a hoot. Those of you who know him know what I'm talking about. But yeah, people call him Bama. He's from Alabama. And yeah, he's got a similar kind of boisterous, booming voice that like Jim has. So he's a joy to be around. And it'll be cool to have him on camera. Yeah. But anywho, yeah. And you probably wouldn't have been included in the episode statistically, says Ken. I don't know, because I was talking to some of the people who were in that, and they're like, yeah, if you look the part, they'd put you in. Something tells me I would have been included, but I don't know. We'll see. Yeah. And Dan the BC Man, they did not pay anybody for filming. That's the thing, is that, I don't know. It cost the museum a bunch of money to have the film crew there, and I don't think they got reimbursed. And nobody on camera got paid a dime for that. You know, we can talk to Don about that. Ethan was in it too. And, you know, let's go ask him, actually. Yeah. Man, it is getting hot out here. Gosh darn. Yeah, let me find a safe place to step.
Or we could just go swimming.
Here.
No, you can't go swimming.
Oh, dang.
Right here.
No swimming for you.
Here, we got a chat question for you, Dawn and Ethan. Well, what did you spend the money on? All the money you got from being in the BBC's Walking with Dinosaurs. How much did they pay you?
We got no pay. We didn't even get lunch. We got nada. We got less than nothing. They took, and never gave a thing.
BBC is not gonna like that you're
But we did have an excuse to sing the Austin Powers BBC song on many, many occasions.
Excellent, yeah. So again, this is what I'm talking about. People expect that, like, oh, you're in paleontology, you must be making the big bucks, you know? Dinosaurs are big business, right?
When they filmed at the, when they came to the Core Center and filmed at the Utah Raptor Block all day for like what is like maybe 45 seconds of footage in the show. Yeah. They did buy us lunch that day.
They did buy you lunch.
Yeah, that day they had Apollo Burger.
Apollo. Yeah. The place that we went with Karen, the little like fast casual place. Yeah. They should have taken you out to that Indian restaurant. That place is great.
Well, we didn't go. They just got takeout.
Oh, okay.
But then we had a BLM chaperone for each day of filming, and he was like, "These guys are cheap. Every other film crew I've been on, they buy you lunch." But those are like Hollywood movies. And
gotcha. Yeah. Yeah.
No, I understand they can't be.
I'm sure they didn't have the biggest budget, but
they had a pretty big
still, I don't know. That's the thing is that, like, just about any time you see a paleontologist in a documentary that's unpaid, like you've been in several, and yeah, it's
now other than the fame and glory for the 15 minutes of the evening.
There you go. Yeah. Have you ever like encountered somebody on the street and they're like, "Oh, did I see you on TV?"
No, they usually just say, "Are you Bill Nye?"
Nice.
Or no more like, "You look like Bill Nye."
Bill. So there you have it. Yeah. It's good that Don's in good spirits. It's good to have him back. I'm happy about that. Clearly, he's happy to be back too. But yeah, we don't get paid for stuff like that. It's kind of nuts, you know. I've been talking about this with some colleagues actually. Like, how do we change that expectation? Because like, if you have people showing up on TV news, like, you know, politicians or political talking heads or whatever, they're usually getting paid to be on TV and to give their expert opinion on things. But scientists, when they appear on TV, it's just expected that, like, oh yeah, you know, of course you're going to do this for free. And we usually say yes because we're passionate about this and we want to see good information distributed out to the public. You know, we want to get the real facts out there, and so usually we kind of nod our heads and naively say, oh, you know, I'm doing this for the good of mankind, so, you know, it's okay that you don't pay me. But we're usually not that well paid to start with. And I don't know, it does strike me as an injustice, you know? I wish we lived in a world where, you know, if a TV network has the money to pay a politician or a political consultant or whatever other talking head they bring on, like, maybe throw a few bucks to the scientists too, you know? But that's just not the way the world works, unfortunately. Not right now. We could change that, but before we do that, we gotta talk about it, you know? Yeah. Let's see. And Alyssa says, "This is so awful. You guys are experts in your field. How do they do this to people?" I mean, it's just that. It's like, well, you know, they're scientists. They're just happy to be on TV, you know? They don't deserve to get paid. A full-on explicit thought like that. Like, maybe there isn't any reasoning that goes into it. It's just like, well, it's kind of the way things have always gone, you know? I guess we could pay them, but the thoughts never occurred to us. I don't really know. I've not done a ton of media appearances. I've done a few. I did that one with GB News. It's on the YouTube page. And talked to Michael Portillo on the air. I woke up at 3 a.m. to be able to do that, because it was broadcast live. That was cool, but you know, there was never any consideration that I would get paid. That never even came up, you know? It was never a thought. I'd like to make it so that I want to live in a world where that is at least a thought, you know? Like, maybe scientists deserve to get paid to make media appearances. Yeah. Anywho. Yeah. Grise says, gotta go on Ancient Aliens. Oh boy. They wouldn't like what I'd have to say. Scientists silenced by History Channel. Yeah. They would cut it anyway, says Sushi Cat. Yeah. 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 And it then did says, Dr. No was rich. What, the Bond villain? What kind of doctor was Dr. No? Is he a medical doctor, PhD, psychologist? What was his doctorate in? Geologist? I don't think so, Claire. Probably a physicist, Charlie Strick. Maybe. Yeah. And Niffler says GB News has the same political leanings as Fox. That's what I'd always heard, yeah. So that's the thing. I got an email, or maybe it was a Twitter direct message, Twitter DM, from one of the producers at GB News asking if I'd be willing to appear in a segment about the commercial fossil trade. This is about Shen, the T-Rex specimen that was slated to go up for auction, and then people realized that there was a lot of shady stuff going on, so the auction was canceled. So anyway, I think it was canceled while we were getting ready for this interview. But anyway, yeah, and I said, yeah, I'll appear there. Sure, that sounds cool. And the whole time I was just girding myself to be like, okay, shoot, Danny, this is it. You've got to really plead your case that these fossils belong in museums, that important scientific specimens, you know, should be studied scientifically rather than being some one person's private property. You know, like, had my whole soapbox all prepared for this, and I was, you know, going on there ready for it to be super contentious, because, you know, this is a right-wing TV network, right? And I get on there, and Michael Portillo was absolutely lovely. He was totally on our side. He's like, yeah, isn't this, you know, he didn't say it, but, you know, you should watch it. We can get a link to it in the chat for you. But our side is like, you know, shouldn't these things be studied by science? Isn't that the point of digging up fossils? So it went very differently than I was expecting, and I was really happy about it. You know, pleasantly surprised, thrilled even. Yeah. Thank you, Claire. That's it. Beautiful. Yeah. And the Raven says, I would be surprised if they did not twist whatever you said after filming. No, it was all live. Afterward twisting, there was no editing. It was just, you know, it went out live, which is cool. Yeah. So again, shouts out to them. It's funny, there's sometimes you'll have like a news enterprise like that, like GB News or New York Post, that like maybe doesn't have the best reputation. New York Post is kind of a rag, let's be honest. Yeah, a lot of they publish a lot of unsavory stuff. It's not particularly thoughtful or kind toward immigrants or minorities or like that, you know. I'm not really a fan of the New York Post, but they had a brilliant article on Dolly, the diplodocid dinosaur that Kerry Woodruff was working on. I think the title was something like The Sad Story of Dolly, the Diseased and Doomed Dinosaur. And so they just reported on the facts there, and then they literally just had a video interview with Kerry Woodruff, who was working on the specimen. He's an old friend of mine from Montana. And it was brilliant, you know? That's excellent science journalism, where it's like, here's a cool thing, and then here are these ideas straight from the scientist. No editorializing, no editing, it's just, there it is. Like, here it is in the researcher's own words. And it was brilliant, you know? Kind of shocking coming from the New York Post, but sometimes they get it right, you know? Yeah. All the time, and that interview, because I think they may have been the only the only news enterprise, the only website, newspaper, whatever, that actually reached out to Carrie and said, hey, let's do a video interview with you and let's get this in your own words. It's great. It's good science journalism. But yeah. Anywho. But yeah, let me go get some more water. And yeah, there you go, Claire. Thank you for posting. Claire is on the ball today. Thank you, Claire, for posting that link. Click that. It's a cool little article about Dolly the dinosaur. Carrie Woodruff nicknamed it Dolly after Dolly Parton, who Carrie has a deep and abiding love for, with good reason. Dolly Parton's a lovely person, seems like. Never met her, but every indication that she's pretty awesome. Yeah. And there's my water. We'll go for about another half hour here, and then I'll wrap things up and continue digging. We'll probably go for like an hour after I stop. There we go. And Gullway says Dolly the sheep was the first mammal clone. This is true, yeah. We've talked about that on stream a bunch of times, and it's something we will be talking about again in the future, I'm sure, when, especially like with all this colossal biosciences stuff coming out. Mammals, as it turns out, are much easier to clone than reptiles. Reptiles also includes birds. Sauropsids versus synapsids. Synapsids are mammals, sauropsids are reptiles, including birds. Birds evolved from dinosaurs. Dinosaurs are a kind of reptile, so birds are a kind of reptile. The tricky thing about cloning reptiles is that their eggs are very, very large compared to the size of the embryo when it starts off. Placental mammals, mammals that give birth to live young, that's all the mammals except for platypus and echidna nowadays, they have extraordinarily small eggs, basically microscopic, and then the glowing like blastocyst, the zygote, the embryo as it grows, it's super, super small. And so you can take a nucleus out of a fertilized egg and then put it into another one really easily. You cannot do that with reptiles, as I understand it, because their eggs are just too large compared to the size of the embryo that's going to grow inside of it. It's just really, really, really tricky, and nobody's been able to figure out how to do that yet. And people have tried. So this whole talk of bringing back moas and dodos and other extinct birds like that, I wish them all the luck in the world. I sincerely hope that it works out, but again, it feels like hype, and I don't know how they're going to get over that. I hope they do, but I hope to be wrong though. Yeah. And Pate B says, I never thought about that, Danny. Got it. Yeah, I know, right? Pretty cool. Yeah. So yeah. And Gran Bridget says that company is just a scam anyway. I mean, I have mixed feelings about Colossal. I think they're doing some cool work and stuff that could be really impactful for conservation biology. I mean, while they had the whole direwolf thing, which I think was kind of a fiasco, they also did some stuff to like increase genetic diversity in the red wolf, which is a very threatened animal. They could easily go extinct if we don't do something about this. And yeah, they were able to do some cool work there. I forget the specifics. Again, it got basically no attention compared to the direwolf stuff. But Yeah, like there's really cool work that they're doing. It's just that's not the stuff that gets hyped up. So I don't know. I'm cautiously optimistic about colossal biosciences, but we'll see how things go, you know? I don't want to be a complete naysayer about that sort of thing. I guess in the way that I am about AI. I'll put it that way. I have fewer negative feelings about colossal biosciences than I do about all that AI garbage hype. Yeah. Just to put things into perspective here. Yeah. Yeah. And Gren Bridget says, did you see the thing they called a dire wolf? It's not even close. Well, that's the thing, is we don't really know what a dire wolf looked like. The biggest thing about that is that, I don't know, the paleontologist, my first thought is, what is a dire wolf? You know? They're claiming that it's very closely related to a modern gray wolf, that they're members of the same genus, that they're sister taxa, essentially. That, like, the dire wolf, Canis dirus, would have been the closest relative to the gray wolf, or something. But the paradigm that a lot of Pleistocene paleontologists have been working last decade has been that the dire wolf is not a wolf at all. It's not even in genus Canis, like wolves and dogs and coyotes. Instead, it's part of an earlier branching group. So the general kind of consensus, as I understand it, was that the dire wolf is not a wolf, it's Anision dirus. It's been renamed, put into its own genus. It's a different thing. And so you can't just take a modern wolf and then change a few different genes. It was like fewer than 20, I think. And then claim that it's a dire wolf, because a dire wolf is maybe completely on the other side of the dog family tree, not even closely related. So, like, you're not going to get anywhere close to that by manipulating a wolf genome. So I don't know. That's what I'm eager to hear about, is Colossal claims to have been able to get DNA from dire wolf fossils and actually make a new phylogeny and figure out, oh yeah, it actually is closest to the gray wolf, but none of this stuff is published yet. In science, you got to show your work, you know? You have to be able to demonstrate that you know what you're talking about and that you've done the work that you say that you've done, you know? You don't take things on faith in science. You demonstrate, you show evidence. And Colossal hasn't done that yet, to my knowledge. And maybe they're right. Maybe they did make some groundbreaking DNA discoveries that show, hey, shoot, it actually is a kind of wolf. I don't know. We haven't seen that yet. They haven't shown us the goods. Yeah. So anywho, yeah. But yeah. Anywho. Any other questions about what we're doing out here? Maybe let's page through that book again real quick, and I'll show you a few things. Before we started the stream today, I was chatting with Selena about like how old the rocks are here and that kind of thing. Did we do that on stream too? But yeah, we've got kind of on the same token of like uncertainty in science, different viewpoints. There's some uncertainty about exactly how old these rocks are, and there probably will be for a while. But let's take a look at this. See if I can find a strat column with, yeah, there we go. So here are some Mesozoic rocks that we have here in Utah. So Triassic, Jurassic, Cretaceous periods. Some of these you might be familiar with, like the Morrison Formation at the end of the Jurassic. We've got dinosaurs like and Stegosaurus, Diplodocus and Brachiosaurus from the Morrison Formation. This is the Cedar Mountain Formation where we're working in right now. The Cedar Mountain Formation is the very beginning of the Cretaceous period. Go. You can look out there and see kind of the rim of the bowl there, moving up through section through these different rocks. They get younger as you go up. And we have this in this diagram right here too. So this is Utah Raptor Ridge, which is just a few miles in that direction as I understand it. And so it's underlain by the Morrison Formation with those Jurassic dinosaurs like I just mentioned. And then you've got different members within the Cedar Mountain Formation. The Yellow Cat, the Poison Strip, the Ruby Ranch, and then up top, we've got the Natarita Formation. If you go west of here, you can get to a spot where they've got Mustn't Touch It member as well. And that's a photo there. I did a stream from here with Jim last year actually we were sitting right over here. We talked about this on stream yesterday. But the Mustn't Touch It is like the beginning of the late Cretaceous. Still in the Cedar Mountain Formation, but within a formation you can have different members like that. And so we're in the Yellow Cat member. Jim likes to divide this into the upper and the lower Yellow Cat. And even each of those might be subdivided into different faunas. You could have a ton of time represented in the Yellow Cat member here. Could be tens of millions of years potentially. We're still figuring out some of those details. That's part of what we're doing here in the quarry, and that's some of the work that Selena does. Like she said earlier, if you want to actually figure out what's going on in these ancient ecosystems, how these animals are evolving, figure out all that stuff, your baseline, the thing you got to figure out first, really, in order for any of this to really make sense, is you've got to figure out the times, those dates. You've got to figure out how old these rocks are, how much time is represented here. Without that, you're kind of spinning your wheels to a certain extent. So yeah, it's cool how much knowledge is accumulated about the Cedar Mountain Formation over the past 3 decades. Because like 30, 35 years ago, nobody really knew or cared about the Cedar Mountain Formation. There are books that say, oh, Cedar Mountain Formation, I guess we'll list it for the sake of completeness for Utah, but they're kind of boring gray rocks, and they're noteworthy for their complete lack of dinosaurs. Nobody cares about the Cedar Mountain Formation, was the idea. And Jim started going out and looking and finding dinosaurs in the Cedar Mountain. And now that's the majority of the dinosaurs that are known from Utah. The holotypes we have from Utah are from the Cedar Mountain. It's so many different critters, so many different dinosaurs still known from Utah raptor, Moabosaurus, iguanodonts, ankylosaurs, theropods. Within theropods you have dromaeosaurs and therizinosaurs and ornithomimosaurs and oviraptorosaurs. And maybe some other guys too. There's a tyrannosauroid from the Cedar Mountain. That's Moros, right? And Moros intrepidus. We didn't know about any of these guys 30 years ago. So it shows just how quickly these things can change. Where suddenly the Cedar Mountain is like the hot spot in Utah. The Cedar Mountain Formation, the rocks that are exposed throughout the eastern part of the state. This is the hot place to be. If you want to study dinosaurs in Utah, this is the new frontier. This is where you want to be at. And there are other crews out here working right now, like at Don's Ridge. We'll hopefully be visiting those folks tomorrow. I say we, I don't know if I can stream from there. But, it's cool to be part of this, and it's cool to be able to share it with you. I guess that's my point. Yeah. And there you go, Golkanek, yeah. And Starmy says, why did they believe the Cedar Mountain Formation didn't have dinosaur fossils? Was it a lack of prospecting? Prospecting the wrong areas, or some other reason entirely? I think it's largely because the Morrison Formation, which underlies the Cedar Mountain, you've got so many big, impressive dinosaurs. It's this classic dinosaur fauna. Stegosaurus, Diplodocus, Brontosaurus, Allosaurus, Brachiosaurus, they're all from the Morrison. So when you think of Utah dinosaurs, you would think of the Morrison Formation. And when field crews would go out to look for dinosaurs in Utah, they know that they could find them in the Morrison. It's a sure bet. You're going to find them there. And so maybe people looked through the Cedar Mountain a little bit and didn't really find anything. And they said, oh, you know. They mostly used the Cedar Mountain Formation as like a, where they're like, okay, Morrison Mountain, don't look there. You're not going to find anything. Dinosaurs bothered to look that hard. But you had people like Jim Kirkland and Don DeBlue and Scott Madsen go out and start exploring, finding them. So yeah, it's, I guess short answer is, why did people think the Cedar Mountain didn't have dinosaurs? Because the Morrison has so many, and it's so world famous, it's like, of course, if you're going to come to Utah, you're going to look in the Morrison. Nobody's going to waste their time looking for information where people assume there's no dinosaurs. And thus nobody looked. And the dinosaurs that we do find here are not easy to get. That's the thing. I think that's one of the reasons why we're a little bit, why Jim isn't so leery about saying where we are. Like I've been saying Doling's Bowl all summer. That's the name of this little valley here. And like, you get rockhounds and people who show up, look for things. You know, they're after the agates or arrowheads and stuff like that. But if they find a dinosaur bone on the surface, they're probably not going to know what it is, because the bone here is not pretty. It generally looks all scrunched up. It's not this beautiful kind of jet black bone that you get in the Morrison Formation. The Cedar Mountain really makes you work for it. The bone is not aesthetically pleasing when you find it on the surface, and it's not easy to dig. The Morrison bone is beautiful, and often very easy to dig. Sometimes. So yeah, does that make sense? Yeah. And XV Empire says, "Hey bro, what's your favorite dinosaur?" Welcome XVN Pyre. I almost said X. It's good to have you here. Shoot, you know, this is a question I get a lot. And it's probably true that, you know, somebody's favorite dinosaur does say a lot about them. My favorite dinosaurs, plural, kind of tell a story about my career so far. So Triceratops is one of my very favorite dinosaurs, because I've dug up a lot of Triceratops out in Montana over the years. Probably a dozen, 2 dozen, maybe 3 dozen different sites digging up Triceratops over about 6 or 7 years in the field. Yeah, another favorite dinosaur would be Triararchuncus, which is a contemporary of Triceratops, lived at the same time. It's a little bizarre, very bird-like, skinny dinosaur with super short arms with one huge thumb claw on each hand. May have only had 1 claw on each hand total. We don't really know. But we know that it's got a big, stupid-looking, like, hooked thumb claw on it. The claw is, like, practically as long as its whole arm is. It's a cool animal. But my crew named that dinosaur. So I'm one of the authors on the original scientific paper describing that animal in 2020 in the journal Cretaceous Research. I really like spinosaurs like Baryonyx, because I'm working on that group right now, hoping to publish that soon. Other dinosaurs. Leptoceratops is another one of my favorite dinosaurs, also from the Hell Creek, with Triceratops and Triararchuncus, because I had the privilege of working at a very cool Leptoceratops site. And I like that it's an underappreciated little dinosaur, Leptoceratops. It's pretty neat. I like it a lot. We've got some exciting stuff coming out about Leptoceratops in the next few years, so stay tuned for that. It'll change the way you think about that dinosaur and all of these leptoceratopsids too, and even up to things like Protoceratops. Yeah, and then this is one of my favorite dinosaurs as well. It doesn't have a name yet, but this iguanodont that we're digging up here, it's an animal that would have looked something like this patch that I have on my bag. That's an iguanodontid. That's iguanodon right there. Our guy is about 20 million years older. Not as big. Probably didn't have a big thumb spike like iguanodon. Not totally sure yet. But that's what we're digging up here. And once this critter gets named, it's going to become one of my favorites too. It already is one of my favorites just because of my proximity to it. That once it gets published, we'll finally be able to put a name to a face, so to speak. Oh yeah. Yeah. Good stuff. Anyway, man, it is hot. I'm gonna get some more water. This is our first, like, legitimately hot day, I feel. It's almost reassuring in a way, though. Like, it's supposed to be hot out here. Sure, it's a lot cooler under those shade tarps. Oh yeah. Yeah. Let's see. Desert Rule says, have you seen any living dinosaurs? Yeah, I saw one bird today. One bird all day. It was a hummingbird, and it came right under our, right under the garages. Which is pretty cool. Yeah. It was we set up a hummingbird feeder there. It zoomed around for a while. Didn't see it. I think maybe it was just kind of curious who and what we were. All these people there. I don't know if that hummingbird sees people very often living out here. Could be migrating through the region. Maybe this is not its permanent home. But I filled up the hummingbird feeder the other day because it was getting really low, and I sincerely hope that they're just swarming that thing while we're gone, and then as soon as we get back to camp, they disappear. I really hope that they're getting some good sustenance out of that, because I worked hard to make that hummingbird food and hang it up high. You know, I had to climb on some boxes to do it. I'm not that tall. So yeah. Anywho, yeah. And let's see, someone asked you for a book on hadrosaurs. Do you have any suggestions? Hadrosaur books. There's a technical book called Horns and Beaks, and it's about ornithopods and marginocephalian dinosaurs. I think Peter Dodson may have been the chief editor on that, Horns and Beaks. But that's like a technical book. It's basically a compilation of scientific papers. It's not really for a general audience. Book on hadrosaurs. That's a good question. I don't know. For dinosaurs in general, I would say Thomas Holtz's Dinosaurs. Just search Holtz, Holtz, Encyclopedia, and you'll find it. Big green hardcover book. Beautiful illustrations in it by Lewis Ray. Why? So if you just search Holtz, Ray, Dinosaurs, it'll come right up. That book is from like 2007 or something, so it's a little bit... Shoot, it's almost 20 years old at this point. But I don't know if anybody's produced a better dinosaur encyclopedia since then. It's kind of for all ages, so you'll enjoy it, and your kids will enjoy it. Your grandmother will enjoy... I don't know. Not all grandmothers like dinosaurs. But yeah, it's a good book. I think it'd be a good place to start. It goes through all of Dinosauria, so just looking at different groups of dinosaurs, and there's some lovely chapters on iguanodontia, including the iguanodontids and the hadrosaurs, the duckbills. So I'd recommend that one. Yeah. Yeah. And that's the one, Claire. Yeah, you get it for less than $11. That's awesome. Yeah. Pretty neat. And Starman says, are there formations that are currently seen as poor in fossils that might need a second look? The one we're working on in Wyoming. Yes. Ethan's been all about that. Yeah. That's a big deal. And, yeah, shoot, there are other formations around the U.S. that there are dinosaurs in, and they've just not been really well studied yet. The Neslin Formation, which you can actually see out there, the Book Cliffs, a lot of that is Neslin Formation, apparently. There are a few dinosaurs that have been named from there. Rhino Rex is one of them. Yeah, but it's poorly studied, and it's not easy to work out there. You know, a lot of the outcrop is really vertical, requires a lot of climbing and hiking, and it's just not easily accessible. That's one of the reasons why it's poorly studied. But there's good plant fossils from there, and there's a few dinosaurs in there too that have been found. Let's see. I think there are other geological formations that are kind of understudied. There's the frontier formation, Montana and Idaho. We've got dinosaur footprints from there, but not a whole lot of... There will be dinosaur body fossils in there, I presume. They just haven't been found yet. Likewise, the Kootenai Formation in Montana, which I think is like beginning of the late Cretaceous, essentially, I think. There's going to be dinosaurs in there, too. I don't know if anybody's been named yet out of there. And so many different geological formations in Mexico that are just begging to be prospected, and there just are not a lot of resources, you know. Mexico should be one of our new frontiers for dinosaur discovery, and hopefully that'll happen. From what I understand, things are going a lot better in Mexico than they have been lately. The political situation there has really improved. Yeah, the average income is going up, people's quality of life is increasing, I think the violence is decreasing. I'm really hoping that this is the beginning of a beautiful new era for that country. In part because, shoot, it would be so cool to be able to do field work there and find new dinosaurs. Denver Fowler from North Dakota, from the Badlands Dinosaur Museum, he's done some field work down there recently. And he's been collaborating with Mexican paleontologists and students and finding some really cool stuff. And being able to correlate that to the fossils that we find up here in the U.S., figure out, are the ages the same? Are they different? What does this say about the way that dinosaurs are evolving through time? It's all really fascinating stuff. It's exciting work. Yeah. And, yeah. And Paddle123 says, what's the permitting process for digging on BLM land? Do you have to restore the site? So we will have to restore the site when we're done, but we've got a good working relationship with the Bureau of Land Management. And let me explain what that means for everybody who's not in the know. The rocks that we're working in here, this land, belongs to the people of the United States. This is public land, federal land. So the way that works is, you know, when the United States was established as a country, federal government formed, there was this expansion out into the West. Many of the people who lived here originally were pushed out, and that's a shameful period in American history that kind of continues to today. But anyway, Utah used to be part of Mexico. And then there was the Mexican-American War, and the U.S. claimed a lot of that territory that used to belong to Mexico, and that includes this area here. Utah used to be part of Mexico. And so American settlers from back east came out west. You know, there were the Mormons and all of them and other settlers too. And they homesteaded land, so they're able to basically claim it, and the federal government gave them paperwork saying that it belonged to them. But a lot of that land, because there's so much of it out here, nobody wanted. So it wasn't good for farming. This area here is really dry. You know, terrible farmland. You could try and grow cactus or something maybe, but to eat. Yeah, probably not very. The point is, there was a lot of land that nobody wanted. Too far from water, too dry, can't do agriculture. Yeah. And so the federal government says, okay, we're going to administer these lands. These are going to be federal public lands that everybody in the country can enjoy. You can go camp out here for free if you want to, all of that stuff. So the Bureau of Land Management was formed to help administer these lands. And the BLM, they can give companies permits to do logging, to like harvest wood and stuff, or mining. Sometimes they get called the Bureau of Logging and Mining. because in some people's opinion, they're far too lenient about that kind of thing, and they let companies kind of run roughshod. I hear a bird. Anyhow, the BLM, I've got a lot of respect for them because they're often in kind of an impossible position where you get conservationists who say you're being far too lenient about these companies, and then the companies, you know, have got a lot of resources and a lot of political clout, and they say you're being far too restrictive. And then you get people like paleontologists who are kind of in the middle, being like, hey, we really, you know, want these preserved as wilderness, but we also want to be able to dig here. The BLM is just pulled in a lot of different directions, and they're often put in an impossible spot, you know? So anyway, federal land belongs to we the people of the United States. We as paleontologists want to come out and prospect, so we apply for permits to the Bureau of Land Management. And so what that entails is you've got somebody from an institution who can vouch for you. So say, hey, these are professional paleontologists, they know what they're doing, they're not going to start fires or, you know, we're just out here looking for fossils, doing science, not for profit. That's a big thing too. We're not going to be selling these fossils. Everything we find is going to go to a museum. Since the land belongs to we the people, the fossils do too. They belong to every American. Not for private ownership, but they need to be held in the public trust. So anyway, you apply for a prospecting permit, and so we got that. And then once we found stuff and decided we needed to dig a big hole to get it out, then you apply for what we call an excavation permit. So in order to do that, you detail where the site is, you kind of explain what you plan to do, what kind of impact that'll have around the surrounding environment. And you also have to outline, here's the museum that we're going to send all these fossils to. And it has to be like an accredited, proper museum with a proper federal repository status. And then, if you do everything right, they'll grant you a permit. There is always a chance that, like, digging at this site, we might somehow harm an endangered species or something like that. But, you know, you can tell out here in the middle of nowhere, there's not a lot going on. So just digging a little hole in the ground is not a big deal, especially when it's already in the wash, you know? Wash is what we call this like dry stream bed. And so when you do get the monsoons that come through, there's just going to be a torrent of water going through this and on it too. But the point is, like, this is not prime habitat for any endangered species. It's the middle of a wash, you know? So, yeah, working under permit on public land, there are things that we have to adhere to, but it's honestly stuff we'd be doing anyway. All of us respect this land. We've got an abiding love for desert environments. Like, we love being here. We want to protect this place. We appreciate this as much as anybody, you know? So we're not leaving trash anywhere. We're not, you know, digging a giant latrine and all pooping into it or anything. We pack all that stuff out at the end of the summer. We're not polluting or doing anything like that, you know? We're trying to be as respectful as we possibly can be to the land and all the organisms that live here. So yeah, I hope that makes sense. And Greasy says every American doesn't have permission to see the fossils that aren't on display, though, do they? Well, I mean, if you come in with that attitude and you're like all aggressive, then no, they're not going to let you into the secure area at the back of the museum. But yeah, the thing is, if you have like a genuine, legitimate interest in seeing some of the fossils that look kind of crummy, the ones that aren't on display, like you're interested in it for research purposes, or like maybe you've got a sentimental attachment to a certain kind of dinosaur, like, yeah, my uncle was on that crew, I'd love to be able to see that dinosaur, see this fossil organism, whatever, write an email to the collection staff. You know, it's kind of like going to an art museum and being like, you know, I have an absolute right to see every painting in here and to, you know, touch it with my fingers. It's like, that's not the way to get anywhere. These fossils are public property, you know? They belong to we the people. And you as an American do have a right to see them. But you can't be a jerk about it, you know? If you're to talk to somebody like me, or a museum curator, collections manager, preparator, whoever, like, yeah, you can get into the collections in the back and take a look at things. But in order to do that, you know, it's kind of like a favor, you know? The people who work at museums are often underpaid and overworked and don't have a lot of spare time. So they'd really be doing you a solid to, like, walk you back there personally to see these things. And occasionally things do get stolen too. We've had that happen at a few different museums that I've worked at, where I've heard stories. You know, there was that Tyrannosaurus lower jaw that somebody stole from Berkeley. Somebody let them into collections when maybe they shouldn't have. And they ended up walking out with a T-Rex jaw in their backpack, and they ended up trying to sell it on the black market. It was recovered by the FBI at one point. It's a whole thing. But yeah, I don't know. I'm a firm believer that, like, if a fossil is interesting to the public and if it can teach them something, we should try and put it on display if we can. But museums often have limited budgets, limited space. If we took every bone that we dug up from here and put it on display, people would think that that was the most boring exhibit in the world. It's like, what's this big lump of crummy bones that just look like rocks, you know? The stuff that you're seeing on display is usually the creme de la creme. Those are the prettiest, most interesting, most charismatic specimens. You know, if we just had a giant drawer full of, well, a giant display case full of little crummy coprolites and stuff we dug up from this quarry, you would cruise on past that at the museum. You wouldn't give it a second look, because it's interesting from a scientific standpoint, but from, like, a public viewpoint, who cares, you know? So yeah. But yeah, anyway. Public spaces, public access. Yeah, there you go. And Sazzle Shake says it's a balance between money, display, education, and security. It's true. Yeah. Yeah, that's why I think this kind of, like, outreach that I'm trying to do, I like to think that this is important. I don't know what it is about the internet, but you get so many people who go, like, well, you know, museums they're hiding things from the public. I've seen the documents, folks. You know, they're hiding giants in the Smithsonian. And you just get this nonsense spread around online, and it's, like, deeply frustrating to somebody like me, where I want the public to be able to see everything that we do. That's why I'm streaming right now. But also, people aren't that interested for a lot of this stuff. I don't know. There is, like, almost a hostility toward the idea of museums from some members of the public. They think, oh, you've got this big museum and you're hiding all these things in it. It's like, we're not trying to hide them. Really, really not. You know? I've been so lucky that the Utah Geological Survey, which is part of the state government of Utah, they've been really supportive of, you know, being able to show this sort of thing to the public. Whether it's through photos and social media, whether it's through public talks, whether it's through these live streams, whether it's through whatever. It's been really cool, you know? I like to think that, I'm sure we've got some people watching right now, or, you know, because, 413 people watching right now? There's at least a couple people in there who are watching this broadcast this very moment and going, like, oh, what are the paleontologists hiding? Let's figure. It's like, I'm trying to make things as transparent as I can, and pretty much all of us in this science are in the same boat. We're all trying to do the same thing. I like to be able to show you just unedited, unvarnished paleontological fieldwork. This is what we do, and this is why it's important, you know. And the more familiar that people in the general public become with that, I think the more they'll support it. We've seen that play out on this, you know, here on Twitch, where we've been able to fund a bunch of paleontological fieldwork through viewer contributions. So yeah, this kind of outreach does bear fruit. It's important stuff. Not to toot my own horn about it, but Yeah. Let's go take a look around the quarry, speaking of this kind of thing. Oh, nice. Nick, you got that bone jacketed. Heck yeah. I feel better about that now. No, it's not gonna... It'll be safe overnight, really.
You and me both.
Yeah. Yeah.
So he spent time with Andy. Yeah.
Yeah, so... Got a humerus right there. That's an upper arm bone from these iguanodontian dinosaurs. This, we don't know quite what it is that Nick is working on at the moment.
Something cool.
It is something cool, something big. If that were like a huge iguanodont fibula, that would be really cool. It'd also be really cool if it were from a theropod, one of these meat-eating dinosaurs. So, we'll find out in the lab. Yeah.
The ants are coming out.
Yep.
Ant time.
And I had this jacket over here. I still got to label this and map it and everything. But this is that rib that I got out just before lunch today. Really weird looking jacket. But you can actually see the outline of it. There's the end, and it's kind of plunging down that way. Up to about here. It flattens out under this part. These are these little plastic tubes that I put in from the Gypsona roll in order to help brace this and keep it from flexing so the thing doesn't crack in half as it's being transported. But yeah, it's a weird looking jacket, but I think it's gonna work pretty well.
Just
In there long enough for some...
Probably not super high priority, it's probably just a rib, but worth collecting. And then we've been kind of disappointed there haven't been too many other big, cool looking charismatic bones that have popped up yet.
squirt out.
But
Oh, gross.
we'll
Do you need tweezers?
get more soon, we hope.
No, it's good. It squirted out. It was just pussy enough to...
Gross. It's just pussy enough.
Gross.
Bad
Bad hand week here.
Was that a pimple or a boil or
No, there was a splinter.
a splinter? Oh, okay.
You know, sometimes you get a little fluster for a few days.
Oh yeah, yeah. Till they're right.
I mean, actually, I didn't know that was in there till earlier.
Nice.
Throw a little extra coat on there, make it nice and strong. That's good for now. Ultimately, it's going to be God, what goes in plaster jackets?
Burlap?
Ultimately, we're going to need to use burlap, so I wouldn't.
It's been a long day and it's hot out here.
No, this is, I just did two, and then that's just so that I can clear stuff around it a little bit more comfortably,
Yeah.
and then also
Perfect.
if stuff falls on it, I'll feel a little
No,
bit
yeah,
better.
that was the move for sure. Yeah, when it comes time to collecting it, we'll do burlap.
That's got two coats.
Yeah, so it's nice.
Nice.
I mean, I
So anyhow, this jacket right here, this big white one, we found most of this last summer. And
GSA abstract of doing a few days.
but that's cool. There's a bunch of limb bones in there. There's a big old femur, big old tibia, some other limb bones. I'm not even sure what they are. And they're all crossed over each other like pickup sticks. That's going to be so cool to open up in the lab. And some of those bones are going to be really scientifically useful because you can cut them. You can do a histological analysis. You cut the bones open, you look at the growth rings in the inside under a microscope, kind of like you do for the growth rings on a tree. And you can figure out how old the animal was when it died. And this is immensely useful for dinosaurs in particular because they change so much as they grow and mature. If you want to be able to figure out who's the same species and who's different, first you got to sort out other variables, you know? Got to figure out who's old and who's young, because it could turn out that you have two dinosaurs that look very, very different from each other. They got to be different species, right? And then it turns out one's young and one's old, and they just changed that much during their lifetime, but they're the same species. This has happened a number of times with different dinosaurs. There's a lot of examples of this. So yeah, it's important stuff. Yeah. And dinosaurs did lay eggs, DCI Banks. Yeah, as far as we know, all species of dinosaurs laid eggs, just like birds today. Today all birds lay eggs. Birds are the descendants of Mesozoic dinosaurs. We don't have eggs from every single group of dinosaurs yet, but that's because we think that certain dinosaur groups laid soft-shelled eggs, and so they're much more difficult to preserve. It's much more unlikely that you'll find them if they're soft-shelled. Hard-shelled eggs, much easier to fossilize, because you're already starting off with something really hard. It can get mineralized easily, but soft-shelled eggs, it requires much more specific conditions to preserve them. We think that the first dinosaurs probably laid soft-shelled eggs, and then, do crocs lay soft-shelled eggs today? I don't think they're hard-shelled, like chickens. Anyhow, so the ancestral dinosaur laid soft-shelled eggs, and then different groups of dinosaurs eventually evolved harder shells for various reasons. And those are the ones that preserve a lot more easily. Yeah. Jerk? Yeah. Yeah. And which groups do we have eggs for? We have sauropod, theropod. From Taurus, we have eggs from those guys. We have eggs from titanosaur sauropods from South America and from Europe. We have eggs from theropod dinosaurs, oviraptorosaurs. We have probably Deinonychus eggs from the Cloverleaf Formation. And I think there was a paper suggesting that they laid blue eggs because you can actually sometimes find color cells in the eggshell that tell you what color the eggs were in life, which is really neat. Yeah. But other groups of dinosaurs, I don't know if we have ceratopsian eggs yet. They may have laid soft-shelled eggs, leathery eggs. I know everybody used to think we had Protoceratops eggs, but those turned out to be oviraptorosaur eggs, not from Protoceratops at all. So I don't know if anybody's found ceratopsian eggs. And I don't know if anybody's found any thyreophoran eggs, armored dinosaurs like stegosaurs and ankylosaurs. I don't know if we have that yet. Someday we will. But I think all the other groups we've got covered. Yeah. And there was a paper that came out a while ago about, I think, Massospondylus, which is a prosauropod dinosaur, early sauropodomorph from southern Africa. I think they actually found the remnants of leathery soft-shelled eggs for those guys, which fits with our idea that the first dinosaur laid leathery eggs. And then after that, through the course of evolution, as different groups branch off and diversify, some groups of dinosaurs evolved hard-shelled eggs. But the default, the base state, would have been soft, leathery shelled eggs. Yeah. Let's see. Dacian Wolf asks a really fascinating question. Are there any dinosaurs that were found on all continents? If you're asking about like a particular dinosaur species, then no. There's no one dinosaur species that's been found on all 7 continents. We do have dinosaurs from all 7 continents. Like, dinosaurs as a group lived on all the continents. North and South America, Africa, Europe, Asia, Australia, and Antarctica. We have dinosaur fossils from Antarctica, too. In some older books, from like the 1980s or 90s, popular books, you might find claims that iguanodont lived on all 7 continents. This guy right here. And very similar to the kind of dinosaur that we're digging up in the quarry. But we no longer think that. That's because there were a bunch of dinosaurs from different continents that all got called iguanodont, but they're not all iguanodont. There's a bunch of differences there. You can't call them all iguanodont. They're too different. So, like the one from North America, from the Dakotas, we call that Dakotodon now. The one from Mongolia is called Alterinus now. It's no longer called iguanodon. The one from Antarctica, I think turned out to be a different kind of dinosaur altogether. So yeah. But yeah, I think there were books in the 90s that I read when I was a kid that like, oh yeah, iguanodont's been found on all the continents. Not anymore. Now we recognize that those are not all iguanodon. Yeah. Oh, and Jim says no Psittacosaurus eggs preserved. Jim, do you mean that there have been no Psittacosaurus eggs preserved, or no, comma, there have been Psittacosaurus eggs confirmed? I don't know which one you mean, Jim. But it's good to see you. Glad to hear that that you're back home. I hope Fisher got to his flight on time. Yeah. Oh, soft-shelled. Nice. Okay, so we do have ceratopsian eggs then. If we have Psittacosaurus eggs, then that means ancestrally, yeah, ceratopsians would have had soft-shelled eggs. That's really cool. I'm gonna have to look into this, Jim, because I don't know enough about that. Thank you. But yeah. Let's see. And Hibiscus says, I heard soft-shelled and thought we were going to talk about turtles for a moment. I mean, we can. I love turtles. But, no, we're talking about eggshells. Yeah. And, and Starmy says, I heard that they found soft-shelled eggs in Antarctica. Do you know anything more about that? I do. Are you talking about The Thing from Antarctica? Not the movie. But there is a weird fossil, this weird, like, potato-shaped lump that was found there a number of years ago. It was published around, like, 2020, something like that. And it was interpreted in the paper as a mosasaur egg. Let me see if I can find you an image. Mosasaur egg, Antarctica. Here we go. It is right there. It looks kind of like a potato that somebody forgot on the barbecue for a week. But yeah, so this has been interpreted by that team as the egg of a mosasaur. So Mama Mosasaur would have expelled that egg out of her cloaca, maybe after the hatchling had already emerged from it. So the idea is that maybe mosasaurs were ovoviviparous. So they're kind of in between an egg-laying animal and an animal that gives live birth. There are some sharks that are like this and some snakes that are like this. And some lizards too, I think. Where they'll still produce an egg with eggshell and yolk and everything else, but the egg hatches inside the mother, and then the baby crawls out, gets expelled out, and then afterward, the spent egg also gets pooped out. So that might be the case with that. Although I have, there's another illustration. Yeah. But I've also heard other people push back against this idea and say, it's probably not the case because of this reason or that reason. And I don't have a horse in that fight. I don't work on mosasaurs. I don't really know a lot about eggs. That's outside my realm of expertise or strong opinion. I'll put it that way. Yeah. But yeah. So mosasaurs would not have crawled onto shore to lay their eggs, says Dr. Hubbs. As far as we know, hardly any marine reptiles would have done that during the Mesozoic. You would have had some exceptions like turtles. Sea turtles, even today, still lay their eggs on the beach. But plesiosaurs, mosasaurs, ichthyosaurs, maybe even marine crocs, like the Thalattosuchians, or things like Metriorhynchus, those ocean-going crocky guys. They may have all given birth to young in the ocean. With plesiosaurs and ichthyosaurs, we know this for a fact, because we found inside the body cavity of a mother ichthyosaur and plesiosaur, we found embryos in there. And they're way too big to have been prey. They're the same species as the adult. Those were embryos, fetuses, essentially. Yeah, pretty cool. Yeah. So yeah, Dr. Hobbs, pretty cool to think about. Like, marine reptiles during the Mesozoic, super cool. Just wild. Supremely well adapted for life in the ocean. Would have been able to completely, abandon all connection to life on land. Wouldn't even have come up to lay their eggs anymore. Completely committed to life under the waves. It's pretty neat. Yeah. Yeah. And let's see. Oh, and Jim says not preserved, so soft-shelled almost certainly. Oh, you're talking about... Was there like an egg clutch of Psittacosaurus found without the eggs? So like the eggs rotted away and you just have the skeletons left? Huh. Interesting. Cool. We had another question from Crimson. Besides Giraffe and Titan, did Brachiosaurus get lumped in a lot around the world and through the early Cretaceous? Because in some books they place Brachiosaurus in Europe and the early Cretaceous. I've seen some estimates pushed to 112 million years ago. So that might be the European brachiosaurs, things like Lusotitan. I think before those things actually got named, people would just refer to them as brachiosaurs or brachiosaurus. Oh yeah. But I'm not sure about the specifics. I'd have to go through some old books and see if they're referring to Lusotitan or see if it's just a mistake or something. I don't know. Yeah. Yeah. And Hibiscus makes a good point. Mosasaurs would have been big enough to like crush their lungs if they came up onto the beach. It might be right. Yeah. Yeah. But on the same Saur, I figure would probably do better than a whale on land. Maybe not because of anything to do with bone density or lungs or anything, but just based on the virtue of mosasaurs being horizontal swimmers and whales being vertical swimmers. So mammals generally have vertically undulating spines, whereas reptiles have horizontally undulating spines. You know, how a snake goes like this on the ground and not like this. You know, and a dolphin swims like this, but not the other way. Yeah, I wonder if horizontal undulation is easier to do on the beach than vertical undulation. Just a guess. I'm thinking out loud here. I'm speculating. I don't know. This is a little brainstorm. Yeah. Maybe it's the opposite. I don't know. And Starmy says, I imagine the Stegosaurus found in Portugal isn't a Stegosaurus either. We're still figuring that out. Yeah. Jim was talking about this the other day. They do have Stegosaurs from Europe, things like Dacentrurus and Miragaia, and there are some authors who argue that those are the same dinosaur between England and Portugal. And there are some authors who think that they're different. I don't have a horse in that fight. I don't know enough to have an opinion. So yeah. Yeah. And let's see.
Ontogeny.
This says, though, have got legs that they use for walking around. If we're talking about mosasaurs and plesiosaurs, they haven't got legs anymore. They got flippers. So it would have been a very different... The limbs of crocs like are adapted for weight bearing. So they actually have like a strong connection to the rest of the skeleton to a certain extent. Whereas I don't think that's the case for plesiosaurs or mosasaurs anymore. I'm pretty sure their limbs are kind of free floating in the skeleton. Yeah. Let's see here. Thank you, InGen728 for the Prime sub. Really appreciate that. Appreciate the support. Yeah. And Le Petit Prince. Being out to the water, big issue for us walking where humans now. Yeah, I mean, like, our upright stance as humans gives us a lot of problems. Like, if we still don't have all the kinks worked out, the upright walking thing. But, we do also have, like, the vertical undulation thing going on. That's just a mammal trait, you know? We've inherited that from our mammal ancestors. That's the direction, you know. That's our... what's the word that I'm looking for? That's our inheritance. Is the fact that our spines bend this way and not really side to side very well, you know? Yeah. And Solitary Jerk says, have you ever found a fossil of a dinosaur in an area that you didn't think would have been there? No. The only places I've ever found dinosaur fossils are in areas where we know that we've got rocks of the right age and the right type. I've been surprised to walk over to a particular hillside and find a dinosaur there. The chasmosaur that I found back in 2012, that was immediately next to a site that had been worked in years prior. And so it just hadn't been exposed yet when that old site was being worked. So it does go to show that, like, you know, even if you think an area has been well prospected, new things can pop up year to year. But it's not like I've ever been looking in, you know, marine strata from the Cenozoic and found a dinosaur or something. It just doesn't happen. You got to look in rocks of the right age and the right type to find dinosaurs. It's kind of the whole point of geology, biostratigraphy, all that, you know. Crazy surprises are few and far between, because generally we understand how the way that the world works. We understand the geological timescale. We understand what's going on at certain times in Earth history. The details in many places are still very hazy, and that's exciting because we have so many things that you have to figure out. But you know, you're not going to find dinosaurs in rocks from the Precambrian era. You're not going to find non-avian dinosaurs in Oligocene rocks in Wyoming. It's just, everybody looks and nobody's ever found one. And the same way that, like, you know, if you're out hiking in the Rocky Mountains, you're unlikely to find an elephant walking around up there. Or if you're canoeing through the Amazon, it's not very likely that you're going to encounter a sperm whale. It's just the wrong habitat, you know? It'd be big news if you did. And this is all talking about critters that are still around today. We're not even getting, you know, we're not even looking at that time axis, you know? Yeah. But yeah, William Smith's law of fossil succession in action. There you go, Dr. Hubbs, yeah. Anywho. And Utah Raptor 14, welcome. Yeah. But yeah, and Jen Alex, yeah, that was, again, that's hippos in Central America. That's pretty cool, though. Yeah. And there you go, Goganek, yeah. Yeah. Let's get some more water. And then, shoot, it's 5:30. I'm going to wrap up this stream pretty soon. I got to get back to digging. Yeah. Oof. All right. Been going for 3 hours, 32 minutes. Shoot. Half an hour longer than usual. I still have to label that jacket and write the data cards and everything for it and get that thing safely stashed. So let's wrap this thing up, shall we? Don't go away just yet. We're going to go right into somebody else, hopefully doing some science on Twitch. We'll see. There we go. Who else is on? Scrolling. Oh, let's go right into Nerduino. He's a former NASA scientist doing some space science news today. Oh. Raid. Nerduino. Excellent. Yeah. Thank you, everybody, for being here today. Thank you for your questions, for your enthusiasm, for your kind words. Everybody who contributed financially by subscribing or gifting or cheering. That's literally the reason I can be out here. Thank you for that financial support that makes these streams possible. Couldn't do it without that. So thank you. And of course, thank you to the moderators for keeping this a safe and welcoming community for viewers of all ages and backgrounds of all sorts. I appreciate you mods more than you know. Thanks for helping keep me sane too. Appreciate it. We may not be streaming tomorrow. We might be going on another field trip to visit another crew having a GAM, as we talked about earlier, with the Los Angeles crew out there. So we'll see. May or may not stream tomorrow. Tune in and find out. Anyway, everybody, take care, and let's go right into Nerduino. I'll see you there. Bye-bye.